The wind moves across the open plain with nothing to slow it. It carries powdered snow, dry grass, and the smell of distant animals over a landscape that would be almost unrecognizable today. There are no roads, no fields, no permanent villages, and no borders except rivers, cliffs, forests, and ice. Herds of reindeer press through the cold in long moving lines. Horses paw at frozen ground. Farther south, straight-tusked elephants browse along lake margins during warmer intervals, while mammoths, bison, rhinoceroses, and giant deer occupy a world that repeatedly expands, contracts, freezes, and thaws. Somewhere beyond the shelter of a limestone ridge, a small group of people is keeping a fire alive. Their bodies are compact and powerful, their faces are unfamiliar, but their actions are not. They choose dry fuel, watch the wind, shape stone, prepare food, and make decisions that will determine whether everyone reaches the next season. Before we go deeper, take a moment to like the video and subscribe. If this is the kind of history and mystery you enjoy, the world these people inhabit is often reduced to a single phrase, the Ice Age. Yet the phrase is misleadingly simple. There is no one frozen landscape stretching unchanged across thousands of years. The Pleistocene is restless. Glaciers advance and retreat. Temperatures rise and collapse. Sea levels fall so far that coastlines shift outward, connecting regions later divided by water. Forests spread during milder phases, then withdraw as open grasslands and cold steppes return. In some centuries, valleys become rich hunting grounds. In others, the same valleys may become difficult corridors swept by cold winds. Neanderthals live through many of these changes, not as passive creatures trapped in an icy backdrop, but as populations repeatedly adjusting to a moving world. Their range extends across much of Europe and into Western and Central Asia. They occupy Atlantic coasts, Mediterranean woodlands, river valleys, high plateaus, and continental interiors where winter can be severe. Some groups live near caves, while others camp in the open. Some know landscapes of snow and sparse vegetation. Others move through milder regions where oak, pine, and grassland form shifting mosaics. The popular image of a permanently frozen Europe inhabited by fur-covered brutes tells only a small part of the story. Neanderthals are not creatures of ice alone. They are creatures of instability. Their true challenge is not simply cold, but unpredictability. That unpredictability leaves its mark on everything. Food cannot be assumed. Wood may be abundant in one period and scarce in another. Animal herds change their routes as climates shift. Springs fail, rivers alter course, and familiar plants disappear from local valleys. A group that survives must remember where shelter lies, where stones suitable for tools can be found, when herds cross a pass, and which routes become dangerous after heavy snow or flooding. Much of this knowledge never fossilizes. It passes through observation, repetition, imitation, and perhaps forms of communication whose complexity remains uncertain. What survives in the record suggests that Neanderthal life depends on far more than physical strength. It depends on accumulated knowledge held within small communities. Their world is also darker than ours in a literal sense. Deep caves are absolute blackness beyond the reach of daylight. Winter nights are long. Fire changes this relationship with darkness. It provides warmth, protection, light, and a place around which tasks can continue after sunset. At Barnham in eastern England, evidence announced in 2025 suggested deliberate fire-making around 400,000 years ago, possibly by very early Neanderthal-related populations. burned sediments, heat-fractured flint, and pyrite brought from elsewhere point toward more than simply preserving a flame found in nature. The identification remains cautious because no human fossil was recovered at the site, but the possibility matters. To make fire is to stop waiting for lightning. It is to carry warmth as knowledge. Across this enormous span of time, Neanderthals leave behind traces so incomplete that almost every reconstruction begins with absence. A hearth is found, but the voices around it are gone. Stone flakes remain, but the wooden shafts, bindings, containers, bedding, and clothing usually decay. Animal bones bear cut marks, yet the gestures and decisions that produced them cannot be replayed. A cave floor may preserve ash, pigment, broken tools, and a few teeth, while entire generations vanish without leaving anything recognizable. Archaeology therefore works with a biased archive. Stone survives better than fibre. Bone survives better than skin. Caves preserve more than open plains. This imbalance once shaped the way Neanderthals were imagined. Because researchers found heavy bones and rough stone tools, they pictured heavy minds and rough lives. Because wooden architecture and clothing rarely survived, they assumed little had existed. Because symbolic evidence was scarce, they treated symbolism as absent. Yet absence in the archaeological record is not always absence in life. A hide shelter can vanish completely. A woven cord may survive only as a microscopic fragment attached to stone. A carefully worked wooden spear can remain preserved only when waterlogged sediments protect it from decay. The deeper investigators look, the more the old image begins to fracture. Even their bodies tell a more complicated story than the stereotype allows. Neanderthals are strongly built, with broad chests, muscular limbs, and large joints. Their shape is often interpreted partly as an adaptation to cold, because compact bodies conserve heat more effectively than long, narrow ones, but no single explanation fully accounts for their anatomy. High activity levels, inherited evolutionary history, diet, and regional variation also matter. A Neanderthal living in the Levant is not simply a copy of one living in Ice Age France or Siberia. To call them builders, then, does not begin with walls. It begins with the construction of survivable space. A fire transforms a patch of ground into warmth and light. A windbreak changes exposure. A hide covering turns weather into shelter. A stone edge changes an animal carcass into food. Sinew, hide, and bone. A planned route turns a dangerous landscape into remembered territory. These acts are easy to overlook because they do not resemble cities, monuments, or temples. But in the Pleistocene, survival itself is an engineered condition. There are moments when the landscape seems to close around them. Glaciers push south, habitats fragment, populations shrink into refuges where food, shelter, and familiar routes remain available. At other times, warmer climates open vast territories again. Neanderthals move into regions that had become uninhabitable, carrying technical traditions and social knowledge with them. Their history is not a straight march toward extinction. It is a long sequence of expansions, retreats, local disappearances, and returns. For hundreds of thousands of years, they endure changes that would erase many other populations. The first clues to who they were are scattered through this unstable world: a fire preserved in ancient soil, a tool transported far from its geological source, a butchered animal beside a vanished lake, a campsite arranged with enough order to suggest repeated habits. None of these alone proves that Neanderthals thought as modern humans do. Scholars still debate how much intention, symbolism, and social complexity can be read from such remains. But together the clues begin to form a picture. These are not beings merely enduring cold through instinct. They are learning landscapes, controlling materials, cooperating, remembering, and repeatedly rebuilding the conditions of life. And still, for most of human history, no one knew they had existed. Their bones lay beneath cave sediment and quarry debris, waiting to challenge a much later species that had grown accustomed to seeing itself as singular. When those bones finally emerged, the discovery did not simply add another extinct creature to the record. It disturbed the boundary around humanity itself. In the summer of 1856, workers cutting through limestone in the Neander Valley near Düsseldorf exposed a small cave and began clearing away the sediment inside. They were not searching for ancient humans. They were removing material from a landscape already being reshaped by industry, and among the debris they uncovered a heavy skull cap, thick limb bones, ribs, and fragments of a pelvis. Some of the remains were discarded before their significance was understood. What survived passed into the hands of a local teacher and naturalist, Johann Karl Fuhlrott, who recognized that the bones were not ordinary. They were human-like, yet strangely formed. The brow ridge was pronounced, the skull was long and low, the bones suggested a body of unusual strength. To Fuhlrott, they belonged to a person from an immensely ancient past. That conclusion was far more disruptive than it may sound now. European scholars were accustomed to studying extinct animals, ancient tools, and old civilizations. But the idea that other forms of humanity had lived before recorded history remained deeply uncomfortable. The biblical chronology still influenced public understanding, and even many scientists who accepted an ancient Earth were reluctant to imagine that human beings themselves had changed. A fossil elephant or giant reptile could be placed safely in a vanished world. A human-like creature with a different anatomy was harder to contain. The bones from the Neander Valley therefore entered a debate larger than the cave in which they had been found. One explanation was that they belonged to a modern human deformed by disease. Another suggested a soldier from some recent European war, perhaps a Cossack whose powerful frame and bowed legs had been shaped by a lifetime on horseback. The skull's heavy brow and unusual proportions were interpreted not as evidence of another human population, but as pathology, injury, or individual peculiarity. The possibility that the bones represented a distinct ancient people seemed too radical to some observers, and not radical enough to others. Fuhlrott and the anatomist Hermann Schaffhausen argued that the remains were genuinely ancient. Their case gained force because stone tools and extinct Ice Age animals were already forcing scholars to reconsider the depth of human prehistory. In the same decade, discoveries in European river gravels and caves showed that people had lived alongside mammoths, rhinoceroses, and other animals long vanished from the continent. Then, in 1859, Charles Darwin published his work on evolution by natural selection. Darwin said relatively little about human origins in that book, but the implication was unavoidable. If life changed through time, humanity could not remain entirely outside the process. In 1864, the geologist William King proposed a scientific name for the Neander Valley individual Homo neanderthalensis. With that act, the bones became more than an anatomical curiosity. They became the representative of a possible human species. The name itself carried uncertainty that has never completely disappeared. Were Neanderthals a separate species, a subspecies, or a regional human population closely connected to our own ancestors? Different classification systems have offered different answers, and scholars still debate how sharply biological categories can be drawn among ancient populations that sometimes exchanged genes. Yet the naming marked a decisive shift. Humanity had acquired a known relative. The valley specimen was not, however, the first Neanderthal fossil ever found. Earlier discoveries had simply gone unrecognized. In 1829, part of a child's skull was recovered from Engus Cave in Belgium. In 1848, a skull from Forbes's quarry in Gibraltar revealed many of the same features later associated with Neanderthals. Neither discovery immediately transformed science, because researchers lacked the comparative framework needed to understand them. The bones existed before the category did. Only after the Neander Valley find gave the ancient population a name could earlier remains be re-examined and placed within the same widening pattern. More fossils followed, in caves across France, Belgium, Croatia, Italy, the Levant, Iraq, and Central Asia. Excavators found robust skeletons, teeth, skull fragments, and stone tools. The scattered remains revealed that the Neander Valley individual was not an isolated abnormality. These people had occupied a vast region over an immense span of time. They varied from place to place, but certain anatomical traits recurred: large brow ridges, projecting mid-faces, long skulls, powerful limbs, and bodies generally more compact than those of many recent humans. The more material emerged, the less plausible it became to dismiss Neanderthals as diseased modern people. Yet recognition did not immediately bring understanding. The first major reconstructions were shaped by poor evidence, cultural prejudice, and a powerful desire to arrange evolution as a ladder rising toward modern Europeans. One of the most influential images came from the Neanderthal skeleton found at La Chapelle-aux-Saints in France in 1908. The individual was elderly by Paleolithic standards and suffered from serious arthritis, tooth loss, and other degenerative conditions. When the anatomist Marcelin Boule reconstructed the body, he portrayed it with a stooped posture, bent knees, a forward-thrust head, and a shambling gait. The reconstruction made Neanderthal anatomy appear almost ape-like. Boule was an accomplished scientist, and his interpretation reflected the knowledge available to him. But the damaged condition of the skeleton distorted the result. Features caused partly by age and illness were treated as characteristics of the entire population. Later reassessments showed that healthy Neanderthals stood upright and moved in fundamentally human ways. Their spine, hips, knees, and feet did not force them into the crouch posture that became famous in textbooks, museums, and popular illustrations. Even after the anatomy was corrected, the image endured. The hunched caveman had become culturally useful. He represented the primitive past against which modern humanity could measure its supposed ascent. This habit affected more than posture. Neanderthal tools were described as crude, their hunting as reckless, their social lives as limited, and their disappearance as evidence of inevitable inferiority. They were cast as evolutionary failures waiting to be replaced by cleverer modern humans. Every difference was read as deficiency. Their strong bodies implied weak intellects. Their limited surviving art implied limited imagination. Their small populations implied social incompetence. The assumptions often ran ahead of the evidence. Excavation methods also created problems. Early archaeologists did not always record sediment layers, spatial relationships, or microscopic traces with the precision expected today. Bones and tools were sometimes removed without detailed context. Collections were separated among museums. Organic materials vanished before anyone knew to look for them. The archaeological record was not only incomplete because of natural decay, it was sometimes further damaged by the methods used to uncover it. Later researchers inherited both the fossils and the gaps. Gradually, the picture changed. New skeletons showed variation rather than a single rigid body type. Careful studies of joints and muscle attachments corrected the crouching stereotype. Experimental archaeology demonstrated that Middle Paleolithic stone tools required planning and skill. Microscopic analysis revealed plant residues, adhesives, wear marks, pigments, fibers, and traces of activities invisible to earlier excavators. Ancient DNA eventually transformed the question altogether, proving that Neanderthals were neither wholly separate strangers nor merely a rough draft of modern humanity. They were a distinct evolutionary population that met and interbred with Homo sapiens. The discovery of Neanderthals therefore occurred twice. The first discovery brought their bones into science. The second, still unfolding, began to free them from the story imposed upon those bones. Each new method has reopened old sites and old collections. A tooth once catalogued simply as human may contain genetic evidence of migration. A lump of mineral may preserve traces of adhesive. A fractured bone may record care rather than weakness. A circle deep inside a cave may reveal planning no one once thought possible. What survives in the record suggests that the greatest obstacle to understanding Neanderthals was never their silence alone. It was the expectation that ancient humanity had to look simple, brutish, and incomplete. Their fossils challenged the uniqueness of modern humans, and modern humans responded by placing them safely below us. The bones did not change, the questions did, and as those questions became more precise, the Neanderthal figure slowly stood upright again. To understand why Neanderthals became what they were, it is necessary to stop imagining Europe and Western Asia as a fixed map. The coastlines, rivers, forests, and plains beneath their feet are constantly rearranged by climate. During colder phases, enormous volumes of water are locked into ice sheets, and sea levels fall. Land appears where water later returns. The English Channel may narrow or vanish as a barrier. Broad coastal plains stretch beyond the edges of modern maps. Valleys deepen, rivers cut different courses, and regions that are now seabed become hunting territory. During warmer intervals, forests advance, wetlands spread, and rising seas divide landscapes that had once been connected. Neanderthals do not occupy one world. They occupy a sequence of worlds layered over the same continent. The rhythm of these changes is not perfectly regular. Glacial and interglacial cycles operate over long spans, but within them come shorter disruptions, sudden cooling events, dry phases, shifts in rainfall, and rapid ecological transitions. A valley rich in deer and woodland resources can become open steppe within generations. A familiar river corridor may freeze longer, flood differently, or lose the plants and animals that once made it valuable. Populations living through these changes must either adapt, move, or disappear locally. The evidence remains incomplete, but Neanderthal history appears full of such local retreats and later returns. Their geographical range is vast. Fossils and archaeological sites place them from the Atlantic margins of Europe eastward into the Altai region of Siberia, and from northern latitudes down into the Levant. This does not mean a single connected population occupied the entire range at once. Instead, separate groups move through shifting zones of opportunity. Some regions become refugees during harsh climatic periods. Others open during milder phases and allow populations to expand. Mountains, deserts, ice, and water repeatedly isolate communities from one another, then reconnect them when conditions change. In Western Europe, limestone landscapes provide caves and rock shelters that preserve some of the clearest traces of Neanderthal life. These places can create a distorted impression because caves survive and attract excavation more readily than open-air camps. Neanderthals almost certainly spend much of their time outside caves, following animals, gathering plants, collecting wood, and moving between stone sources and seasonal camps. Open sites are simply more vulnerable to erosion, farming, river movement, and later construction. The archaeological map therefore shows not only where Neanderthals lived, but where their traces happen to survive. The environments they encounter range from bitterly cold steppe to temperate woodland. During glacial periods, parts of northern Europe are covered by ice or lie close to its margins. South of the glaciers stretches a cold, dry landscape, sometimes called Mammoth Steppe, though its appearance varies regionally. Grasses, herbs, low shrubs, and scattered trees support herds of large grazing animals. Mammoths, woolly rhinoceroses, reindeer, horses, and bison move across open terrain. Predators include wolves, hyenas, lions, and bears. Neanderthals are neither the largest nor the fastest creatures in this world. Their advantage lies in cooperation, tools, planning, and knowledge of terrain. During warmer phases, the same regions can look entirely different. Forests of oak, pine, birch, and other trees spread into areas once dominated by grassland. Straight-tusked elephants, deer, wild cattle, and other animals become important in some local ecosystems. Lakes and wetlands attract dense concentrations of life, at places such as Neumark Nord in what is now Germany. Neanderthals repeatedly use rich lakeside environments during a warm period around 125,000 years ago. The landscape there is not a frozen wasteland but a productive setting of water, vegetation, and large mammals. Evidence from such sites has helped overturn the belief that Neanderthals were narrowly specialized for cold conditions alone. Their success in different environments depends partly on mobility. A small community cannot remain permanently in one location if fuel, prey, or edible plants become scarce. Movement follows patterns that may be seasonal, opportunistic, or inherited through generations. Groups return to known springs, river crossings, caves, and stone outcrops. Some tools are made from material carried tens of kilometers from its geological source, showing that Neanderthals either travel widely or obtain resources through contact with other groups. Scholars still debate how extensive their exchange networks are, but the movement of stone across landscapes reveals territories larger than a single campsite. Knowledge of these territories is a form of infrastructure. There are no signs, maps, or marked roads, yet routes exist in memory. A pass through hills may be safe in late summer and deadly in winter. A cave may provide shelter, but also attract bears. A river terrace may offer flint, while another valley contains better wood for spear shafts. To survive, Neanderthals must connect these places mentally. The landscape is not empty wilderness. It is a network of remembered risks and resources. The Mediterranean regions present another set of possibilities. Coastal zones provide shellfish, fish, birds, plants, and marine mammals in some areas. Although the extent of regular coastal exploitation varies by site and period, lower sea levels mean many ancient shorelines now lie underwater, so evidence for coastal behavior is especially incomplete. What survives suggests that some Neanderthal groups use marine resources and collect shells, sometimes for purposes beyond food. A shell found far from the water may be a transported object, a tool, a pigment container, or an ornament. Context determines meaning, and context is often damaged or missing. Farther east, the Levant acts as a corridor between Africa and Eurasia. Its climate fluctuates between wetter and drier conditions, opening and closing routes through the region. Neanderthals and Homo sapiens occupy parts of this landscape at different times, and perhaps sometimes within overlapping cultural worlds. Sites such as Tinchamet Cave and Uchasla too complicate any clean division between separate species living in separate behavioral zones. Similar stone technologies, resource strategies, and possible symbolic practices suggest that traditions may move between populations or persist across changes in who occupies a site. This does not prove that all groups share identical cultures, but it shows that the boundaries between them may be less rigid than older models assumed. At the eastern edge of the Neanderthal range, conditions become more continental and extreme. Siberian caves preserve evidence of small populations living in cold environments, far from the classic European sites that shape the earliest image of Neanderthals. Genetic studies reveal repeated movement, replacement, and contact among Neanderthals, Denisovans, and other human groups in Asia. A cave can be occupied by different populations at different times, turning one location into a record of human movement across thousands of years. The people never see the full pattern. They know only the groups they meet, the routes they inherit, and the seasons they endure. Climate affects more than where Neanderthals can live. It also shapes population size and connectivity. When habitable zones shrink, communities may become isolated. Small populations are vulnerable to chance a run of poor seasons, the loss of skilled adults, or the failure of a local animal migration can have lasting consequences. When climates improve, groups may expand and reconnect, exchanging genes, tools, and knowledge. This repeated fragmentation and reunion may help explain regional differences in anatomy and technology. Yet Neanderthals are not merely responding to environments, they are altering them on a small but meaningful scale. Fire changes vegetation locally, whether intentionally or accidentally. Butchery sites concentrate bones and nutrients. Repeated occupation transforms cave floors with ash, tools, and discarded material. At Newmark Nord, intensive processing of large animals and bones suggests organized use of lakeside space on a scale once thought too complex for Neanderthals. They are not reshaping continents, but neither are they invisible within them. The most surprising fact about their world may be how often it disappears. Entire coastlines are submerged, open camps erode, forest soils destroy bone, glaciers grind away older surfaces. The map archaeologists reconstruct is therefore made from surviving islands of evidence within a largely vanished terrain. Each cave and river terrace offers only a narrow window. What emerges from those windows is a human population defined not by one climate, but by the ability to live through many. Neanderthals endure cold plains, wooded valleys, dry plateaus, Mediterranean coasts, and distant continental interiors. Their bodies carry part of this history, but anatomy alone cannot explain their range. Survival across such varied landscapes requires memory, flexibility, and social knowledge. The continent changes around them, and for hundreds of thousands of years they change with it. The body that moves through these changing landscapes is built differently from that of most people alive today. A Neanderthal is not simply a modern human with heavier bones, nor an ape-like figure halfway toward humanity. The skeleton follows its own long evolutionary history. The skull is low and elongated, with a broad face, a large nasal opening, and heavy brow ridges that curve above the eyes. The back of the skull often carries a distinctive projection known as an occipital bun. The chest is deep and wide, the pelvis is broad, the arms and legs are powerful, while the lower portions of the limbs are relatively short. Taken together, these features create a compact body capable of generating strength and retaining heat. Cold adaptation is one of the most familiar explanations for this shape. Among many mammals, populations living in colder environments tend to have broader bodies and shorter extremities because this reduces the amount of surface area through which heat is lost. Neanderthals fit that general pattern. Their compact proportions would have offered an advantage during long winters, especially when combined with clothing, shelter, fire, and high-energy food. Yet climate alone cannot explain every feature. Some Neanderthal populations live in relatively mild regions, and their anatomy varies across time and space. Evolution does not design bodies for a single purpose. It modifies inherited structures under many pressures at once. Their unusual nasal region illustrates the difficulty. The broad nose has often been described as an adaptation for warming and humidifying cold, dry air before it reaches the lungs. This remains plausible, but the internal anatomy does not produce a simple answer, and some researchers emphasize inherited facial development rather than a direct climatic function. The projecting midface may also relate to the way the skull grows and how forces are distributed during chewing. Scholars still debate the balance among climate, development, diet, and ancestry. The Neanderthal face may be adapted, inherited, and mechanically shaped all at once. Their bones are thick, but thickness does not mean clumsiness. Muscle attachment sites reveal heavily developed shoulders, arms, hips, and legs. Daily life places repeated demands on the body, walking over uneven ground, carrying meat and fuel, scraping hides, shaping stone, moving through steep terrain, and thrusting or throwing weapons. Much of this work begins early and continues for years. The skeleton records activity in the same way that a well-used tool records wear. Some asymmetry in the arms may reflect repeated movements connected with tool use and hunting. Although interpreting these patterns is difficult, the body is strong because life repeatedly requires strength, not because thought is absent. Neanderthal hands are especially revealing. Their finger bones and joints suggest powerful grips, but they are also capable of precision. They shape thin flakes, retouch sharp edges, work bone, handle fibers, and apply small amounts of adhesive. None of these actions is compatible with the old idea of an awkward hand suited only to brute force. A strong thumb can hold a heavy object securely, but it can also control a fine movement. Experimental studies and tool traces show that Neanderthal technology depends on both power and delicacy. Their feet and legs are similarly human in function. They walk upright with efficient bipedal movement. Earlier images of bent knees and a shuffling gait came largely from the pathological skeleton at La Chapelle-aux-Saints, and from assumptions that difference must indicate primitiveness. Healthy Neanderthals stand erect. Their shorter lower legs may slightly reduce the energetic cost of moving through cold environments, while broad joints help absorb stress. The precise efficiency of their walking and running compared with that of Homo sapiens remains debated, but there is no evidence that they move as half-upright creatures. The size of the Neanderthal brain has long attracted attention. On average, their cranial capacity is at least comparable to that of modern humans and is often somewhat larger. That fact does not prove greater intelligence. Brain size alone cannot reveal how neural tissue is organized, how efficiently it functions, or what kinds of cognition it supports. A larger body generally requires more neural control, and differences in visual processing or motor demands may influence brain proportions. Still, the size makes one point unavoidable. Neanderthals are not small brain survivors operating through instinct alone. Their development from infancy to adulthood may have followed a pattern both familiar and distinct. Teeth preserve microscopic growth lines, allowing researchers to estimate the pace of childhood development. Some studies suggest that certain Neanderthal children matured slightly faster than recent humans, while other evidence indicates a long period of growth broadly comparable to ours. Variation among individuals and methods makes a single conclusion difficult. What survives suggests that Neanderthal childhood is prolonged enough to require years of learning, feeding, protection, and social dependence. Skills such as stone knapping, hunting, fire management, and landscape knowledge cannot be acquired instantly. The body also records injury. Neanderthal skeletons frequently show healed fractures, damaged joints, tooth loss, and repetitive strain. For many years, this pattern encouraged comparison with rodeo riders, as though Neanderthals hunted by recklessly confronting large animals at close range. Close-range hunting certainly carries danger, but the sample is biased. Injured individuals are more likely to attract scientific attention, and some apparent patterns weaken when compared carefully with other ancient populations. Their injuries may reflect demanding lives rather than uniquely reckless behavior. What matters is that many injuries heal. A broken bone that knits over time proves survival after trauma. Severe dental wear and tooth loss sometimes continue for years. An individual with reduced mobility or impaired chewing may need assistance, modified food, or protection. The social meaning of such survival belongs more fully to another layer of the story, but anatomy already hints that the Neanderthal body cannot be understood in isolation from the group around it. Their teeth carry an especially intimate record of life. Neanderthals often use the front teeth as tools, gripping hides, fibers, wood, or other materials. Repeated contact leaves scratches, polish, and heavy wear. Small grooves can reveal habitual hand movements, and tiny defects in enamel record periods of physiological stress during growth. Calculus trapped on teeth preserves microscopic traces of food, plants, and environmental material. A jaw can therefore reveal diet, work habits, development, and illness long after every soft tissue has disappeared. At Chagirskaya Cave in Siberia, a Neanderthal molar described in 2026 appeared to preserve evidence of deliberate intervention in a painful cavity. Marks inside the damaged area suggest that a small stone tool may have been used to remove decayed tissue or relieve discomfort. The interpretation is cautious because ancient damage can have several causes, but the possibility is striking. Such an act would require controlled movement in a sensitive part of another person's body, practical knowledge of pain, and enough trust for the procedure to occur. Even anatomy, usually treated as the most biological form of evidence, begins to open onto behavior. Sexual differences within Neanderthal populations are difficult to reconstruct from incomplete skeletons. Males are generally larger on average, but the degree of difference may not be extreme. Individual variation is substantial. A robust skeleton is not automatically male, and assigning sex from fragmentary remains can be uncertain. Older reconstructions sometimes exaggerated division by imagining males as hunters and females as passive occupants of caves. The bones do not support such simple social roles. Both male and female bodies show the effects of strenuous movement and repeated work. Regional diversity further complicates the idea of a single Neanderthal form. Populations separated across Europe, the Levant, the Caucasus, and Siberia do not remain anatomically identical. Traits shift over tens of thousands of years as groups become isolated, reconnect, and exchange genes. Late Neanderthals may differ in some respects from earlier populations. Contact with other human lineages also introduces variation. The familiar museum reconstruction is therefore a composite, not a portrait of every Neanderthal who ever lived. Even the boundary between Neanderthal and modern human anatomy is not always sharp. Some fossils display combinations of traits, and genetic evidence confirms interbreeding. Biological categories remain useful, but ancient populations do not necessarily obey the clean divisions drawn by later science. A person living 40 or 50,000 years ago could carry ancestry from more than one human lineage, while belonging socially to one local community. Their bodies are unmistakably different, but difference does not place them outside humanity. The broad chest, heavy brow, strong hand, and compact limb are solutions produced by another branch of human evolution. They belong to people shaped by cold, movement, work, inheritance, and time. The real question is no longer whether they looked like us. They did not, at least not entirely. The deeper question is what those different bodies were capable of doing, learning, making, and enduring. The capabilities of those bodies cannot be recovered by measuring bone alone. Intelligence leaves no fossil in the ordinary sense. Thoughts do not mineralize, memories do not remain in cave sediment, and emotions disappear with the people who felt them. What survives are indirect traces: the shape of the brain case, the sequence of childhood growth, the organization of living spaces, the repeated return to familiar places, the treatment of injured companions, and the technical decisions preserved in tools. None of these offers a complete view of the Neanderthal mind. Together, however, they make the old picture of a dim and instinctive creature increasingly difficult to defend. Their brains are large, but size is only the beginning of the problem. The average Neanderthal cranial capacity overlaps with that of Homo sapiens and may be somewhat greater in absolute terms, yet a larger brain is not automatically a more intelligent brain. Neanderthals also have more massive bodies, and some neural tissue must support the control of stronger muscles, broader frames, and highly demanding movement. Brain organization matters more than total volume, and the brain itself is gone. Researchers must work from endocasts, natural or digital reconstructions of the inner surface of the skull, where impressions left by the brain and its coverings offer limited clues about overall shape. These reconstructions suggest that Neanderthal brains are not simply enlarged versions of modern human brains. Their skulls are long and low rather than rounded, and their pattern of brain development appears to differ, especially during early growth. Modern human infants pass through a distinctive phase in which the brain case becomes more globular. Neanderthal infants do not seem to follow exactly the same trajectory. This may reflect differences in the organization of regions involved in perception, coordination, memory, or social processing. But the evidence cannot show precisely how those differences affected experience. A skull reveals geometry, not consciousness. Some researchers have proposed that Neanderthals devoted proportionally more neural resources to vision and body control, particularly because they lived at higher latitudes with seasonal light conditions and possessed larger bodies. Under this model, less brain tissue may have remained available for the extensive social networks associated with Homo sapiens. It is an intriguing hypothesis, but not a settled conclusion. Estimating functional brain regions from fossil skulls requires several assumptions, and cognitive abilities do not divide neatly into isolated compartments. A population can possess exceptional visual awareness, practical reasoning, and social intelligence without organizing those abilities exactly as modern humans do. Their long survival itself demands caution against underestimating them. Neanderthals persist across unstable environments for hundreds of thousands of years. They anticipate seasonal change, recognize animal behavior, locate stone and water, manage fire, and pass technical knowledge between generations. A mind incapable of flexible learning could not repeatedly solve these problems across forests, plains, coastlines, and cold continental interiors. Their intelligence may not mirror that of recent urban humans, but neither does the intelligence required in an Ice Age landscape resemble the skills rewarded in a modern classroom. The measure is not abstract cleverness. It is the ability to perceive relationships, remember consequences, and act before danger becomes unavoidable. Hunting offers one window into this mental world. Large prey cannot be approached successfully through strength alone. Animals detect movement, scent, and sound. They flee, charge, scatter, or defend one another. Hunters must read tracks, wind direction, terrain, herd structure, and the condition of individual animals. They may need to position themselves around a route, conceal their approach, choose a vulnerable moment, and coordinate action at close range. A poorly timed movement can ruin the hunt or cause serious injury. Such behavior requires attention to the intentions of both animals and companions. Toolmaking reveals another layer. Many Neanderthal stone technologies begin with an imagined result. A stone core is prepared so that a later strike produces a flake of a desired shape. The useful edge does not emerge by accident. It is created through a sequence in which earlier removals establish the angles and surfaces required for later ones. The maker must hold a plan across several steps, adjust when the stone behaves unexpectedly, and recognize quality in raw material before work begins. Some tools are then hafted to wooden handles with bindings and adhesive mixtures, adding further stages that must be coordinated. The ability to learn such sequences implies teaching in at least a broad sense. Teaching need not involve formal instruction or spoken explanation. It can occur through demonstration, correction, repeated observation, and shared work. Young Neanderthals likely watch skilled adults strike stone, prepare hides, maintain fire, and process animals. Their early attempts may leave irregular flakes and abandoned cores. Archaeologists sometimes identify pieces that appear less skillfully made than others, raising the possibility that learners practiced beside experienced toolmakers. The interpretation remains incomplete, but complex traditions cannot persist unless knowledge moves reliably from one mind to another. Memory is equally central. Neanderthals return to particular caves and camps over long periods, sometimes across many generations. They recognize places not only as physical locations but as clusters of expectation. A certain valley may hold migrating animals in autumn. A distant outcrop may provide stone that fractures predictably. A sheltered terrace may remain dry when surrounding ground floods. Remembering such patterns allows a group to reduce uncertainty. Shared memory turns landscape into culture. The emotional dimension is harder to approach, yet it cannot be avoided. Neanderthal skeletons include individuals who survive serious injuries and chronic impairments. Some live with damaged limbs, extensive arthritis, or major tooth loss. Their continued survival may indicate assistance with food, movement, protection, or daily tasks. Not every healed injury proves compassion. A capable individual can recover without constant support, and group assistance may be motivated by practical value. kinship, obligation, affection, or several of these at once. Still, repeated cases show that Neanderthal communities do not simply abandon every member who becomes temporarily less productive. At Shanidar Cave in northern Iraq, the remains of several Neanderthals have shaped this discussion for decades. One individual, often called Shanidar, once survived severe injuries that affected an arm, the head, and possibly vision or hearing. He lived long enough for substantial healing to occur. His survival does not allow researchers to reconstruct every act of care he received, but it suggests that disability did not automatically end a person's place within the group. Another individual from the cave, Shanidar Z, was found in a context that may reflect deliberate treatment of the dead. The site continues to generate debate, especially around older claims of a burial accompanied by flowers. What remains important is not a romantic certainty about ritual, but the possibility that bodies, memory, and place were linked in intentional ways. Emotion may also be visible in something less dramatic tolerance. Small communities living under pressure depend on the ability to share space, distribute tasks, manage conflict, and maintain bonds over years. Cooperation cannot be sustained through aggression alone. Trust must exist around dangerous activities such as hunting, fire, medical intervention, and close contact tool use. The possible treatment of a painful tooth at Chagirskaya Cave is a small but intimate example. A person allowing another to work inside the mouth with a stone instrument accepts vulnerability. The action may have been practical rather than ceremonial, but practical care is still care. Communication binds these abilities together. Neanderthals possess a version of the FOXP2 gene associated in modern humans with speech and language, and their throat and hearing anatomy appear compatible with a broad range of vocal communication. Recent genetic work has suggested that some regulatory foundations connected with complex language may predate the separation of Neanderthal and Homo sapiens lineages. None of this proves that Neanderthals spoke languages identical in structure or range to modern ones. Genes do not preserve grammar, and a hyoid bone does not record a vocabulary. Yet the evidence makes a nearly speechless Neanderthal increasingly unlikely. They may have used vocal signals, gesture, facial expression, rhythm, and shared attention in combinations now impossible to recover. Their communication had to support travel, cooperation, childcare, technical learning, and social relationships. Whether it included elaborate storytelling, names for absent places, or discussion of distant plans remains unknown. Scholars still debate where language becomes fully modern and whether that threshold can even be identified from archaeology. The safest conclusion is also the most unsettling to old assumptions. Neanderthal minds are neither transparent nor primitive. They are different minds within recognizably human lives. They remember, learn, plan, trust, adapt, and respond to one another. Their inner worlds cannot be reconstructed in full, but the traces they leave suggest more than survival without reflection. Behind the heavy brows are people attending closely to animals, weather, materials, pain, and companionship. Their intelligence is written not in a single spectacular object, but in the repeated success of ordinary decisions made across thousands of generations. When darkness settles over a Neanderthal camp, survival contracts into a small circle of light. Beyond it, the landscape continues unseen. Wind moves through grass and brush. Large animals cross distant slopes. Predators follow scents through the night. Inside the glow, people work with materials gathered during daylight, dry clothing and hides, divide food, repair tools, and watch the fire that makes the surrounding cold temporarily manageable. The hearth is not merely a source of heat, it is the center of a constructed environment, a boundary between the group and a world that cannot be controlled. Keeping that boundary intact requires attention. A fire must be fed before it weakens, protected from wind, and placed where smoke will not make a shelter unlivable. Fuel varies by location. In wooded regions, branches and deadwood may be readily available. On open or cold landscapes, usable wood can be scarce, forcing people to collect shrubs, bone, or other combustible material. Fuel has weight, and gathering it consumes time. A group deciding where to camp must consider not only shelter and food, but the distance to anything that will burn. Archaeological hearths reveal repeated choices rather than random flames. Ash, charcoal, reddened sediment, and burned bone can show where fires were maintained and how often a site was occupied. At some locations, hearths cluster in particular zones, suggesting that Neanderthals organized activity around them. Toolmaking may occur near one edge, food processing in another area, and discarded material farther away. The pattern is never as clear as the floor plan of a house, because cave sediments shift and later occupations disturb earlier ones. Still, what survives in the record suggests that living spaces were often structured through habit. A well-chosen camp solves several problems at once. It offers protection from prevailing winds, access to water, a view of nearby terrain, and routes toward food and stone. Caves and rock shelters can provide substantial cover, but they are not automatically comfortable. They may be damp, smoky, uneven, or already occupied by bears, hyenas, and other animals. Some have poor ventilation, others face the wrong direction for winter sunlight. Neanderthals therefore choose among shelters rather than simply entering the nearest hole in the ground. The position of a cave mouth can matter as much as its depth. A south-facing shelter may receive more sunlight and warmth. A raised entrance can provide visibility over a valley while reducing the risk of flooding. Nearby water is valuable, but a river that rises suddenly can destroy a camp. Stone suitable for tools may lie within walking distance, while hunting routes pass through the surrounding terrain. These practical relationships turn some places into repeated destinations. Generations return not because caves possess an abstract importance, but because particular shelters work. Open-air camps are harder to detect, yet they may have been equally important. Neanderthals hunt, butcher animals, collect plants, and travel across areas far from caves. Temporary windbreaks, hide shelters, and lightweight structures would leave little trace. Post holes are rare and difficult to identify in ancient sediments. Organic coverings decay. Stones used to secure hides may later be scattered. The absence of preserved walls does not mean people slept permanently exposed to rain, snow, and wind. Their clothing is another nearly invisible form of shelter. Neanderthals live in climates where naked skin would lose heat rapidly, so hides almost certainly play a major role. Stone scrapers bear microscopic wear consistent with working animal skins. Bone tools described from later Neanderthal contexts appear designed to remove hides carefully without tearing them, preserving large usable surfaces. Such skins can become blankets, coverings, bags, footwear, or garments. The exact shapes are unknown. No complete Neanderthal coat survives, and fitted clothing is difficult to prove, but the environmental demands make some form of body covering unavoidable. Preparing a hide is laborious. Fresh skin contains fat and tissue that must be scraped away. It may be stretched, dried, softened, smoked, or treated with animal products. If handled poorly, it stiffens or rots. If pierced carelessly, it becomes less useful for keeping out wind and moisture. This work requires repeated knowledge of texture, timing, and weather. It also turns hunting into more than the acquisition of meat. Every large animal provides a collection of materials: hide, sinew, tendon, bone, fat, horn, and sometimes teeth. The carcass is not one resource but many. Cordage expands what these materials can do. A small fragment found on a stone tool in France and reported in 2020 appeared to preserve twisted fibres associated with Neanderthals. The fragment is tiny, yet its implications are large. Making cord requires selecting suitable fibres, separating them, twisting strands in a controlled direction, and combining them so that tension holds the structure together. Once that principle is understood, cord can bind tools, fasten clothing, secure bundles, repair shelters, carry objects, or form nets and containers. The evidence remains rare because fibre almost always decays, but rarity of survival should not be mistaken for rarity of use. Containers may be among the most important missing technologies. A mobile group benefits enormously from anything that carries water, food, fuel, pigment, or small tools. Bags made from hide or woven material would leave almost nothing behind. Wooden bowls and bark containers are similarly unlikely to survive. Without them, modern reconstructions can make Neanderthal camps look strangely empty, populated only by stone flakes and animal bones. In life, this space was probably filled with perishable objects now absent from excavation plans. Daily survival also depends on maintenance. Stone edges dull, wooden shafts split, bindings loosen, hides tear, firewood runs out, food spoils. A camp cannot be understood as the product of one dramatic act. It exists through repeated small repairs. Much of Neanderthal intelligence is expressed in this maintenance, in recognizing a problem before it becomes dangerous. A damaged spear discovered during a hunt may be useless. A weak shelter revealed by a storm may be too late to fix. Preparation turns uncertainty into something slightly more predictable. Food preparation occupies another part of the hearth-centered routine. Meat may be roasted, dried, or warmed. Bones can be broken to expose marrow. Plants, seeds, tubers, and other gathered foods vary by region and season. Some traces suggest that Neanderthals cooked plant material, though the full range of preparation methods remains unclear. Cooking softens food, changes flavour, reduces some pathogens, and makes certain calories easier to obtain. It also creates timing. Someone must tend food while others complete different tasks. The fire changes social time as well. Daylight no longer sets an absolute limit on activity. Work can continue after sunset. People can remain together in relative warmth while weather closes around a shelter. Communication becomes easier when faces and gestures are visible. Knowledge may be demonstrated, objects passed between hands, and experiences remembered in whatever forms their communication allows. It is tempting to imagine stories told around every hearth, but no evidence can preserve the words. The safer observation is that controlled fire creates the opportunity for sustained social attention after dark. Smoke leaves its own costs. In enclosed spaces it irritates eyes and lungs, blackens surfaces and reduces visibility. Neanderthals must balance warmth against ventilation, hearth placement, cave shape, fuel choice, and wind direction all matter. Some deep cave activities require portable light, perhaps from torches, small fires, or lamps using animal fat. Entering darkness is therefore a technical problem. Light must be produced, transported, and maintained where natural visibility disappears. At Bruniquel cave in southern France, hundreds of broken stalagmite sections were arranged into large circular forms deep underground around 176,500 years ago. That extraordinary site belongs to a later part of the question of Neanderthal building, but its setting already reveals the mastery of fire and darkness involved. The builders moved far beyond daylight, selected and transported stone, and maintained illumination long enough to complete organized work. The cave was not merely entered, a usable human space was created inside it. Most Neanderthal shelters are far less dramatic. Their importance lies in repetition rather than monumentality. A protected sleeping area, a dry hide, a reliable hearth, and a repaired container do not impress the modern imagination in the way a stone circle does. Yet these ordinary technologies make occupation possible across winter, rain, darkness, and distance. The Neanderthal camp is therefore not simply a place where ancient people happen to stop. It is a system assembled from landscape knowledge, fuel, skins, fibers, stone, memory, and cooperation. Each night it must be maintained. Each departure requires deciding what to carry and what to leave. Each return depends on whether the place still offers what the group remembers. In the firelight, their world becomes briefly smaller and more human. The cold remains outside. The darkness waits beyond the entrance. But within the shelter, materials have been transformed, space has been organized, and survival has been built one careful action at a time. Beyond the shelter, the landscape becomes a field of decisions. Tracks cross one another in mud and snow. Broken branches reveal movement. Dung shows what has passed and how recently. Wind carries scent toward or away from a herd. A distant animal may be healthy, injured, separated, alert, or already watched by another predator. Hunting begins long before a weapon is raised. It begins with reading. Neanderthals are often imagined as hunters who survive through raw strength and dangerous close combat. Their bodies are powerful, and many of their weapons appear suited to thrusting at short range. Yet strength alone cannot explain repeated success against animals larger, faster, and better armed than any human. Horses can kick with lethal force. Bison and wild cattle can charge. Rhinoceroses and elephants turn size into defense. Even deer become dangerous when cornered. To approach such animals requires patience, terrain knowledge, coordination, and the ability to anticipate behavior. The wooden spears from Schöningen in northern Germany remain among the most important clues. Preserved in waterlogged sediments, they reveal careful woodworking and aerodynamic design. A revised date published in 2025 placed the main spear horizon at about 200,000 years ago, increasing the likelihood that Neanderthals or closely related populations made and used them. The shafts were shaped from selected wood, balanced, and worked with attention to natural grain. They were not sharpened branches grabbed in desperation. They were engineered hunting weapons. Some appear suitable for throwing, while others may have been used as thrusting spears. The distinction matters because it changes the distance between hunter and prey, but either method requires planning. A throwing spear must be balanced and launched from a useful angle. A thrusting spear must survive impact and be placed where it can penetrate deeply. Hunters also need to position themselves relative to animals and one another. A group approaching horses near wet ground. A shoreline or a narrow passage may be using the landscape to limit escape. Scholars still debate the exact hunting scenarios at Schöningen, but the tools themselves show foresight. Woodworking is nearly invisible at most sites because wood decays. The survival of the schoening and spears therefore exposes a technological world that must once have been far larger. Neanderthals likely made digging sticks, handles, wedges, clubs, stakes, frames, and other wooden objects that have vanished almost everywhere. A stone tool is often only one component within a more complex object. The cutting edge survives, the shaft, binding, and adhesive disappear. At Leringen, also in Germany, evidence from roughly 125,000 years ago presents an even more imposing scene. A wooden spear was found associated with the remains of a straight-tusked elephant, an animal that could weigh many tons. Research published in 2026 strengthened the interpretation that the elephant had been deliberately hunted and butchered. The spear appears to have been used at close range, probably as a thrusting weapon. This was not an animal subdued through physical equality. It was overcome through opportunity, knowledge, and coordinated risk. Straight-tusked elephants inhabited warmer European landscapes and moved through forests and lakeside environments. A vulnerable animal near water or difficult ground may have offered an opening. Hunters could use terrain to reduce mobility, approach from concealed positions, or target a weakened individual. The precise sequence can never be replayed, but the carcass represents an enormous reward. Meat, fat, hide, tendons, and bone could sustain or supply a group far beyond a single meal. The size of such a carcass creates a different problem: abundance. Large quantities of meat spoil quickly. Processing requires tools, labour, time, and perhaps cooperation among more people than a small household group. Some researchers have suggested that elephant hunting implies gatherings of multiple communities or forms of sharing across a wider social network. Others caution that a small group could exploit only selected portions and leave the rest. No single explanation fully accounts for every site. Still, the repeated exploitation of very large animals makes random scavenging an insufficient general model. At Newmark Nord, evidence suggests that Neanderthals intensively processed straight-tusked elephants and many other large mammals over a long period. Cut marks and skeletal patterns indicate systematic removal of flesh, fat, and other tissues. The site lies in a rich lakeside landscape during a warm interglacial, far from the stereotype of desperate hunters wandering through endless snow. Here, Neanderthals appear as skilled users of a productive environment, returning repeatedly and extracting resources with remarkable thoroughness. Another discovery from Newmark Nord has added a surprising layer. Research published in 2025 identified an area where bones from at least 172 large animals had been smashed and processed to obtain marrow and bone grease. Bone grease is not easy food. It requires selecting fatty skeletal parts, breaking bones into smaller fragments, heating them in water, and separating the fat that rises. The process consumes fuel and labour, but it produces valuable calories. This has sometimes been described as a Neanderthal fat factory. The phrase is modern, but the organisational implications are real. Bones appear to have been brought to a particular place, fractured intensively, and treated in ways that suggest planning beyond immediate hunger. Fat is especially important for people relying heavily on lean animal protein. The human body cannot safely obtain all of its energy from protein alone. High-fat resources help meet enormous caloric demands, particularly in cold climates or during periods of intense activity. The Neanderthal diet, however, is not one universal menu. Stable isotope studies often show high reliance on large herbivores in colder European regions, placing some individuals at a trophic level comparable to major predators. Yet dental calculus, microscopic plant remains, tool residues, and site evidence reveal consumption of plants as well. Seeds, tubers, nuts, fruits, grasses, and other foods vary with season and region. Some were likely cooked. Mediterranean groups also use shellfish, coastal resources, birds, rabbits, tortoises, and smaller animals where available. This flexibility matters because older interpretations sometimes portrayed Neanderthals as narrow specialists, unable to adjust when large game declined. The surviving evidence now suggests substantial regional variation. A group in steppe country may focus heavily on reindeer or horse. One near a forested lake may exploit deer, cattle, elephants, plants, and aquatic resources. Coastal populations may collect shellfish and other marine foods. Adaptation is local. Hunting itself probably includes several methods. Ambush is likely important. Animals may be driven toward cliffs, muddy ground, narrow valleys, or other natural traps. Hunters may target calves, isolated adults, or individuals weakened by season. Scavenging also occurs, as it does among most predators and human foragers. Finding a fresh carcass abandoned by another carnivore is an opportunity, not evidence of inferiority. The boundary between hunting and scavenging can be difficult to identify archaeologically, especially when only bones and cut marks remain. Competition with carnivores adds further danger. Lions, hyenas, wolves, and bears occupy many of the same landscapes and caves. A carcass attracts attention. Hunters processing an animal must remain alert, protect food, and decide how much can be transported. Some sites show alternating occupation by Neanderthals and carnivores. A cave useful to people may later become a den. Neither side owns the landscape permanently. The risks of hunting are written on Neanderthal skeletons, though not always in ways that can be linked to a particular animal. Healed fractures and joint injuries show that bodies endured hard impacts and repetitive stress. Close-range encounters likely cause some of these injuries, but falls, travel, tool accidents, and daily labour also contributed. The old comparison between Neanderthals and rodeo riders may capture the danger of approaching large animals, yet it oversimplifies a much broader life of physical risk. Success depends on cooperation. One hunter may conceal movement while another watches the herd. Others may wait near an escape route. After a kill, labour continues through butchery, transport, hide removal, marrow extraction, and protection from scavengers. Meat must be divided, carried, eaten, stored, dried, or shared. A large carcass may briefly change social life by creating surplus and attracting people to one place. This does not mean every hunt is a grand communal event. Much of subsistence may involve quiet, repetitive work collecting plants, trapping or catching smaller animals, gathering fuel, checking familiar places, and carrying resources back to camp. Archaeology naturally emphasizes large bones and stone weapons because they survive. The daily contribution of foods and materials that leave little trace may have been just as important. What does survive shows that Neanderthal hunting is not a contest between muscle and beast. It is a system of observation, technical preparation, coordinated movement, and nutritional judgment. The spear is only the final visible point of a long chain of thought. Before it is used, wood must be selected, shaped, maintained, and carried. Before prey is approached, tracks, wind, ground, and animal behavior must be read. After the animal falls, a new sequence of decisions begins. The hunter and the builder are therefore not separate figures. The same mind that shapes a shaft also chooses a campsite. The same hands that remove a hide turn it into shelter. The same group that surrounds an animal later organizes fire, food, tools, and care. Neanderthals do not survive the Ice Age because they are stronger than everything around them. They survive because strength is joined to knowledge, and knowledge is made useful through cooperation. A Neanderthal tool begins before the first strike. The maker must find stone with the right internal structure, carry it from an outcrop or riverbed, judge its hidden flaws, and decide what form can be removed from it. Flint, chert, quartzite, and other materials do not behave identically. Some break cleanly, others fracture unpredictably. Weathered surfaces conceal weaknesses. A poor choice can waste hours of effort and leave a hunter without a reliable edge. The finished implement is therefore only the visible end of a longer chain of selection, transport, memory, and planning. For much of the 20th century, Neanderthal stone technology was described as competent but conservative, as though these people repeated a narrow set of inherited movements without imagination. That view depended partly on comparing their tools with the thinner blades and elaborate ornaments associated with later Homo sapiens. The comparison made technological change appear like a simple ascent from crude to refined. Yet stone tools are not judged by delicacy alone. A thick flake may be exactly right for scraping hide. A broad point may be shaped for hafting. A heavy edge can withstand work that would destroy a thinner blade. Neanderthal tools are designed within practical systems, not displayed as steps toward modern aesthetics. One of their best-known methods is often called the Levallois technique. The name refers to a family of approaches in which a stone core is carefully prepared before a desired flake is removed. The maker shapes the core's surfaces, controls its curvature, establishes a striking platform, and then delivers a blow intended to detach a flake of predictable size and form. The crucial act is not the final strike. It is the preparation that makes the strike work. Several earlier removals create the geometry of a future object that still exists only in the maker's mind. This requires what archaeologists call hierarchical planning. One action serves a later action, which serves the final goal. If an early removal creates the wrong angle, the entire sequence may fail. The maker must recognize when to continue, when to repair the core, and when the stone can no longer produce the intended result. Different Levallois strategies generate points, flakes, or elongated forms, and regional traditions reveal variation rather than mechanical repetition. Not every Neanderthal tool is produced through Levallois methods. Their technological record includes side scrapers, denticulates with toothed edges, pointed pieces, notches, hand axes in some regions, and many informal flakes used with little additional shaping. The category known as the Mysterian covers a broad range of Middle Paleolithic industries rather than one fixed toolkit. Local stone availability, intended task, mobility, and cultural tradition influence what appears at a site. A group living beside abundant, high-quality flint may discard tools readily. Another travelling through a region with poor raw material may resharpen and carry valued pieces until little remains. This difference creates what might be called a biography of stone. A flake is struck, used, retouched, hafted, resharpened, transported, and perhaps finally abandoned far from its source. Microscopic wear on the edge can sometimes reveal contact with meat, hide, wood, plants, or bone. Residues may preserve traces of blood, fat, fibre, pigment, or adhesive. The stone does not merely show what shape was preferred, It records episodes of work. Hafting is one of the clearest signs that Neanderthal technology extends beyond isolated stone objects. A point attached to a wooden shaft becomes a spear. A cutting flake fixed into a handle becomes easier and safer to use. Joining the materials requires a binding system or adhesive strong enough to survive pressure. At several sites, Neanderthals used birch tar, a dark substance produced by heating birch bark under conditions that limit oxygen. The chemistry can be achieved through more than one method, and scholars still debate how elaborate the earliest production processes were. Even the simplest workable method, however, requires control of heat and recognition that bark can be transformed into glue. Other adhesive mixtures may combine natural bitumen, resin, ochre, or plant material. These compounds must be collected, processed, stored, softened, and applied. An adhesive that is too brittle will crack. One that is too soft will fail under force. Binding fibers may reinforce the join. The maker must align the stone correctly on the shaft and allow the connection to set. A hafted tool is therefore a composite technology, an object in which materials with different properties are made to cooperate. The presence of adhesive also implies maintenance knowledge. A damaged stone point may be removed and replaced while the wooden shaft is preserved. Bindings can be tightened. Glue can be reheated. The tool is not necessarily discarded when one component fails. Such repair reduces the cost of production and allows equipment to remain useful across repeated journeys. Woodworking is central to this system, though the evidence is usually missing. Stone edges bear wear consistent with shaping wood, and rare preserved objects show extraordinary control. The Schöningen spears were straightened, smoothed, and balanced from carefully selected trunks or branches. Making such a weapon without metal demands patience. Bark must be removed, knots managed, surfaces scraped, and the shaft tested by hand. The natural growth of the tree becomes part of the design. Neanderthals also work bone, although bone technology is less abundant than stone. Some bone fragments were used as retouchers to sharpen and reshape stone edges. Others were fashioned into smoother tools. Lissoires, made from ribs and polished through use, were probably used to work hides, compressing fibres and producing a more flexible or water-resistant surface. Similar tools later appear in Homo sapiens contexts, raising questions about technological exchange and independent invention. Their existence among Neanderthals shows that bone was not merely broken for marrow. Its mechanical qualities were understood and selected. New studies of specialized bone implements have suggested that some tools were designed to separate hides from carcasses without puncturing the skin. Preserving an intact hide matters when the material is intended for clothing, shelter, containers, or waterproof coverings. The tool's shape reflects a goal beyond butchery efficiency. It protects the future value of the material. A decision made during skinning influences warmth and mobility weeks or months later. The same long planning horizon appears in cordage. The surviving fragment of twisted fibre associated with a Neanderthal stone tool is small enough to overlook, yet making it requires a conceptual transformation. Individual fibres are weak. Twisted together, they become a strand. Several strands combined in opposite directions resist unravelling and become stronger still. This principle can produce bindings, handles, carrying loops, nets, bags, traps, and perhaps sewn or tied clothing. Once a group possesses the technique, its applications multiply. Because fibres decay, archaeologists may be seeing only the stone and bone framework of a much richer technological world. A Neanderthal toolkit likely includes objects made from bark, skin, sinew, tendon, wood, and plant fibre. There may be pouches holding small flakes, cords securing bundles, wooden digging implements, hide water containers, and mats or bedding. Most vanish without leaving recognizable traces. The surviving stone tools can therefore make the technology appear more limited than it was. Tool production also has a social life. Knapping creates sharp debris that can injure bare feet and hands, so its location within a camp may be chosen carefully. Skilled makers may sit where light is good and raw material can be controlled. Others watch. A learner sees not only where the hammer strikes, but how the core is held, how force changes with angle, and how a mistake is corrected. The sound of successful fracture differs from the sound of a bad break. Much of this knowledge is bodily, acquired through repetition rather than explanation alone. Archaeologists can sometimes reconstruct a knapping episode by fitting flakes back onto a discarded core. Each fragment returns to its earlier position, allowing the sequence of removals to be followed almost blow by blow. These refitting studies reveal movement around a site, the division of material, and the decisions of individual makers. A core may be worked in one area, carried elsewhere, and finished by another person. Pieces separated in excavation become parts of a single ancient event. Regional traditions add another human dimension. Neanderthal groups do not all make identical tools. Even when similar resources are available, certain forms and techniques persist in particular areas, suggesting learned customs passed through communities. Function explains part of the variation, but not necessarily all of it. People often make effective objects in familiar ways because those ways carry social continuity. A tool can belong to a tradition without becoming symbolic. Contact may also spread technology. In regions where Neanderthals and Homo sapiens occupy the same landscapes across time, similarities in stoneworking may reflect shared environmental solutions, inherited traditions, or direct cultural transmission. Sites in southern Turkey and the Levant are especially important because they complicate any expectation that species identity always produces a separate toolkit. The evidence suggests that cultural boundaries can cross biological ones, although establishing who learned from whom is often impossible. The hand holding a Neanderthal tool is therefore not executing a primitive reflex. It is working within a technical tradition composed of material knowledge, learned sequences, repair strategies, and social observation. The maker understands that stone can become an edge, bark can become adhesive, fibre can become cord, bone can become a hide-working implement, and wood can become a balanced weapon. Each transformation depends on seeing not only what a material is, but what it can become. This may be the most revealing quality of Neanderthal technology. Its intelligence lies less in any single masterpiece than in combination. Stone joins wood, adhesive joins stone, cord reinforces adhesive, hide becomes clothing, bone becomes a tool for improving hide, fire transforms raw material and keeps the maker alive while the work continues. The skilled hand is part of a larger system, and behind it is a mind capable of holding several materials, several steps, and a future need together at once. The tools carried away from a campsite are not isolated possessions. They belong to a moving system of people, materials, routes, and remembered places. A stone point found far from its geological source implies distance. It may have travelled in a pouch, remained fixed to a wooden shaft, passed between individuals, or changed hands through contact with another group. By itself, the object cannot reveal the entire journey. Yet its presence shows that Neanderthal life extends beyond the narrow circle of a single cave or hearth. Mobility is often described as wandering, but that word suggests aimlessness. Neanderthal movement is more likely structured by knowledge. groups return to river crossings, sheltered terraces, springs, game corridors, coastal zones, and stone outcrops because these places have worked before. A cave may be occupied for a few days during one season and revisited years later. An open-air location may serve as a butchery site, while another becomes a place for repairing tools or waiting for animals. The landscape is divided not by fences, but by function and memory. Some camps preserve dense layers of debris, suggesting repeated or prolonged use. Others contain only a few flakes and animal fragments, the residue of a brief stop. Archaeologists sometimes distinguish residential camps from specialized activity sites, but ancient behavior rarely fits clean categories. A place used for hunting on one visit may become a shelter during another. Sediment compresses separate occupations together, making several brief events appear continuous. What looks like one large group may actually represent many small groups separated by decades or centuries. This uncertainty makes movement difficult to reconstruct. Stone provides one of the clearest clues because its geological origin can sometimes be identified. At many Neanderthal sites, most raw material comes from nearby sources. This makes practical sense. Carrying heavy stone over long distances costs energy, and suitable rock is often available locally. Yet some pieces arrive from tens of kilometers away, and occasionally farther. Their movement may reflect direct travel, exchange, or a sequence in which objects pass between neighboring communities. Exchange does not require marketplaces or formal trade. Two groups meeting near a water source may share information, partners, food, stone, or finished tools. A visitor may carry an object into a new territory and leave it there. A person joining another community may bring technical habits and material possessions. Archaeology sees only the final location, not the social circumstances that moved the object. Scholars still debate how extensive Neanderthal exchange networks were, but the distribution of raw materials shows that their social world was not confined to the people sleeping around one hearth. The scale of movement varies with environment. On open plains, large animal herds may travel considerable distances, encouraging hunters to follow or intercept them seasonally. In rugged mountains, movement may be channeled through valleys and passes. Forests offer diverse resources but reduce long-range visibility. Coastal zones shift dramatically as sea level changes, exposing broad plains during glacial periods and drowning them when the climate warms. Routes that once connected communities now lie beneath water, taking their camps and resource zones with them. The sea therefore hides part of Neanderthal geography. During periods of low sea level, coastlines may lie many kilometers beyond their modern positions. Rivers cross plains that are now submerged, and caves near ancient shores may have collapsed or disappeared underwater. Evidence for fishing, shell collection, coastal travel, and settlement is consequently biased toward the few locations where old shorelines remain accessible. The surviving sites show that some Neanderthals used marine foods and collected shells, but the scale of this behavior may be underestimated. Movement also depends on what can be carried. A mobile group must make decisions about weight. Stone cores can be transported and reduced gradually, producing fresh flakes along the route. Finished tools may be resharpened repeatedly. Wooden shafts can be repaired rather than replaced. Hides, food, fuel, and containers compete for carrying capacity. Young or injured members may reduce the distance a group can travel in a day, while knowledge of nearby resources can make slower movement possible. Mobility is therefore social as well as geographical. Some Neanderthal communities appear to occupy relatively restricted territories rich in predictable resources. Others move through wider ranges. Genetic evidence suggests that certain groups were small and locally connected, while individuals occasionally traveled between communities. At Chagirskaya Cave in Siberia, ancient DNA revealed close biological relationships among several Neanderthals and suggested that women may have moved between groups more often than men. The sample is limited and should not be treated as universal social rule, but it offers a rare glimpse of movement at the level of individual lives. A person leaving one community for another carries more than genes. That person may bring knowledge of stoneworking, food preparation, roots, remedies, ornament, and social customs. Cultural transmission can therefore occur through marriage-like partnerships, adoption, temporary visits, or group fusion. The archaeological signature may be subtle, a new method appearing in a familiar toolkit, a distant raw material entering a site, or a decorative object used where it had not appeared before. Repeated occupation creates attachment to place. Neanderthals may not conceive of territory in the legal sense, but some locations acquire continuity through use. A cave containing older hearths, abandoned tools, and perhaps the remains of the dead would not be encountered as an entirely empty space. Even if individuals cannot know its full history, visible traces connect the present group with earlier occupants. Ash layers, smoke-darkened ceilings, and familiar working areas make the place already human. At Shanidar Cave, multiple Neanderthal bodies were deposited within the same broad area over time. Whether every individual received deliberate burial remains debated, but the recurrence itself suggests that the cave held importance across generations. At other sites, occupation alternates with carnivores, flooding, or long periods of abandonment. Return is never guaranteed. A valued place may become inaccessible, dangerous, or ecologically useless as climate changes. Climate can fragment movement networks quickly. A colder phase may close northern territories and push populations towards southern refuges. Expanding forests may alter prey routes. Drought may reduce water sources and create long gaps between habitable zones. Small groups separated by mountains, ice, or empty terrain lose access to partners and shared knowledge. When populations reconnect, they may encounter relatives, strangers, or other human lineages. The Levant is especially important because it repeatedly becomes a corridor through which populations move between Africa and Eurasia. Neanderthals and Homo sapiens occupy the region at different times, sometimes using similar technologies and spaces. Evidence from Tinchamet Cave suggests a degree of behavioral convergence among human groups between roughly 130,000 and 80,000 years ago. Stone technology, hunting practices, pigment use, and treatment of the dead may reflect contact, shared traditions, or adaptation within the same cultural environment. Farther north, Uchazla II Cave in southern Turkey has produced evidence suggesting long-term cultural continuity across occupations associated with Neanderthals and Homo sapiens. Similarities in stone tools, resource use, hunting strategies, and shell ornaments blur the expectation that one population's arrival must produce a complete cultural break. The evidence does not prove that Neanderthals and modern humans lived together peacefully or shared every practice. It suggests something more restrained and perhaps more important cultural knowledge may persist across biological boundaries. This possibility changes the meaning of migration. When one human population enters a region occupied by another, the outcome is not limited to replacement or conflict. People may observe one another, exchange materials, imitate useful techniques, form relationships, or absorb members of neighboring groups. Contact can be brief or sustained, cooperative or hostile, and likely varied across time. Archaeology usually preserves the tools after the encounter, not the encounter itself. Neanderthal territories were therefore not sealed worlds. Their edges shifted with seasons, climates, births, deaths, partnerships, and opportunity. Some individuals travelled beyond the landscapes known to their childhood. Others may have spent entire lives moving within a relatively small region, understood in extraordinary detail. A distant mountain, a bend in a river, or the smell of a particular spring could serve as orientation without anything resembling a drawn map. The knowledge required for these journeys is cumulative. Routes must be taught or demonstrated. Water sources must be remembered. Dangerous crossings must be recognized. The timing of animal movement must be estimated. Stories, gestures, or repeated travel may preserve this information. Without such transmission, each generation would face the landscape as strangers, and the cost of rediscovery would be severe. Movement also creates resilience. When local food fails, knowledge of another valley can save a community. Contact with neighbouring groups can provide partners, information, and access to unfamiliar resources. But mobility has limits. A small population cannot maintain connections across every distance. If groups become too isolated, technical traditions may narrow, genetic risks may increase, and the loss of a few knowledgeable individuals can have consequences beyond one household. This vulnerability will become important near the end of the Neanderthal story. For now, their movement shows a world held together by paths that leave almost no trace. They build no roads, yet corridors exist. They draw no surviving maps, yet territories are known. Stone, genes, and repeated camps reveal fragments of those invisible networks. The Neanderthal landscape is not an empty wilderness crossed by solitary hunters. It is a remembered geography of return, encounter, and exchange. Caves become landmarks, rivers become routes. Distant stone carries evidence of connection. Across generations, people move through a world that changes constantly, preserving continuity by carrying part of it within themselves. The paths connecting Neanderthal communities were not carried by tools alone. They were carried by bodies, and bodies sometimes failed. A damaged joint, a missing tooth, a weakened eye, or a severe infection could reduce a person's ability to hunt, walk, chew, gather fuel, or defend against cold. In a small population, where every capable adult mattered, injury was not a private inconvenience. It changed the balance of the group. Neanderthal skeletons preserve an unusually intimate record of physical hardship. Ribs were fractured, limbs were damaged, joints developed arthritis. Teeth wore down until roots were exposed or entire sections of the jaw were left empty. Some individuals survived trauma that would have made ordinary tasks difficult for months or years. The existence of healed bone is simple biological evidence, but its social meaning is harder to measure. Healing proves that the person remained alive. It does not automatically reveal who brought food, adjusted travel, prepared softer meals, or stayed nearby. Yet when severe impairment appears alongside long survival, complete independence becomes increasingly unlikely. The old stereotype treated Neanderthal life as brutally efficient. Under that model, anyone unable to contribute would be abandoned because survival allowed no room for weakness. The fossils do not support such a rigid system. Some people lived long after injuries reduced their usefulness in the narrowest economic sense. Their communities appear to have tolerated dependency, at least in certain cases and for meaningful periods of time. Shanidar-1 remains one of the best-known examples. This Neanderthal man lived in the region of what is now northern Iraq and survived multiple serious impairments. One arm was withered or badly damaged. He had injuries to the head, substantial hearing loss, and other physical limitations accumulated over a long life. Earlier accounts sometimes exaggerated the severity of every condition, but even cautious reassessment leaves an individual who faced real difficulty. He could not have performed every task expected of a fully able hunter. He may have struggled to hear danger or communication clearly. Some forms of tool use and carrying would have been more difficult, yet he survived for years after several injuries had healed. His community did not simply remove him from its social world. He continued to receive access to food, shelter, and protection. There are practical reasons to support an injured person. An older individual may retain knowledge of roots, animals, stone sources, weather, and technical skills. Someone unable to chase prey might still prepare hides, maintain fire, repair equipment, or teach. Care and usefulness are not opposites. A community can value a person emotionally, while also benefiting from experience accumulated across decades. Modern categories such as compassion, obligation, kinship, and utility may all have operated together. The important point is not that Neanderthals practiced idealized kindness. No archaeological evidence can prove the emotional purity of an action. Human care is often complicated, combining affection, duty, habit, expectation, and shared survival. Neanderthals were likely no different. What the bones show is that they sometimes maintained relationships through periods when immediate contribution was reduced. Dental evidence adds another layer. Neanderthals often suffered intense tooth wear because their front teeth were used as tools. Gripping hides, fibres, or would place stress on enamel already challenged by grit in food. Some individuals lost multiple teeth and continued living long enough for the empty sockets to heal. Eating tough meat or raw plants without functional teeth would have been difficult. Food may have been cut into smaller pieces, cooked longer, crushed, or shared in softer forms. These adjustments leave little direct evidence, but they are reasonable inferences from survival. A person with severe tooth loss cannot simply will the problem away. Someone must change either the food, the task, or both. Such accommodation reflects practical flexibility within the group. The molar from Chajyskaya cave offers an even more unusual possibility. Researchers identified marks suggesting that decayed tissue may have been deliberately removed with a stone implement. The procedure would have been uncomfortable, perhaps painful, and required controlled movement in a small area. The interpretation remains debated because damage can occur in several ways. But if the marks do represent treatment, the act reveals remarkable trust. The person receiving assistance had to remain still and allow another individual to work close to the face. The person performing it had to understand that removing damaged material might reduce pain. There was no written medicine, no formal anatomy, and no guarantee of success. Yet practical medical knowledge does not begin with theory. It begins with observing that certain actions help and others make a condition worse. Plants may also have played roles in pain relief or treatment. Traces preserved in dental calculus have led to suggestions that some Neanderthals consumed plants with medicinal properties. These findings are difficult to interpret because a plant may have been eaten as food, accidentally inhaled, used as bedding, or consumed for another reason. Scholars still debate whether particular residues demonstrate deliberate self-medication. The safer conclusion is that Neanderthals possessed detailed botanical knowledge and lived closely enough with local plants to recognize many of their effects. Care appears even more clearly in the case from Cova Negra in Spain. A small fragment of inner ear bone belonged to a young Neanderthal who may have had a condition consistent with Down syndrome. The anatomy suggests serious hearing and balance difficulties. The child survived to at least around 6 years of age, a significant period under Pleistocene conditions. This case must be approached carefully. A diagnosis based on a fragmentary fossil cannot be absolute, and the emotional life of the group cannot be recovered directly. Still, the survival of a child with substantial care needs strongly suggest sustained protection. The support would not have involved only one parent. A mobile community facing demanding conditions may have needed to adjust movement, supervision, and daily labour over years. The significance lies less in assigning a modern moral label than in recognizing social depth. Caregiving can consume time and energy. It may slow travel and require food to be shared with someone who cannot contribute equally. Yet the group continued to make room for that life. The evidence suggests that Neanderthal communities were capable of commitment extending beyond immediate material return. This also changes how their small population size should be understood. Small groups are often described only as vulnerable, and they certainly were. A few deaths or failed births could have major consequences, but small groups can also form intense networks of familiarity. Individuals know one another's abilities, habits, injuries, and needs. Survival depends on predictable cooperation. The loss of one person is not merely a reduction in numbers. It can mean the disappearance of a skilled toolmaker, an experienced navigator, a caregiver, or someone who holds relationships between families together. Daily care probably occurred in quiet forms that never entered the fossil record. Someone kept a place near the fire, someone divided food, someone waited during travel. Someone carried material another could not. Someone watched over sleep when illness reduced awareness. These acts leave no monument, but they are part of the infrastructure of survival. Even hunting depends on this foundation. A hunter takes risks partly because others will respond if something goes wrong. Trust allows people to approach large animals together, carry weapons close to one another, and divide tasks under pressure. The same cooperation that brings down prey also supports recovery afterward. Care is not separate from survival strategy. It is one of its conditions. There may have been limits. Neanderthal communities faced hunger, cold, and dangerous movement. Not every injured individual survived, and not every group could sustain prolonged dependency during crisis. The archaeological record contains bodies whose circumstances remain unknown. It would be sentimental to imagine universal protection. It would be equally misleading to assume universal abandonment. What survives suggests variability within a deeply social species. Some people died quickly, others lived through years of impairment. Some bodies were left where death occurred. Others may have been placed deliberately. Some pain was endured. Some may have been treated. The question of how human Neanderthals were becomes especially difficult here because care is often treated as one of the clearest signs of humanity. Yet humanity does not require care to look modern, formal, or heroic. It can exist as a practical decision repeated each day to share, to wait, to protect, to continue including someone whose body no longer moves as it once did. Their skeletons preserve the damage. Their survival preserves the relationship. Between the fracture and the healed bone lies a span of time archaeology cannot see directly, filled with ordinary acts performed by people who refused, at least sometimes, to let injury erase belonging. A piece of ochre can look insignificant in excavation. It may be no larger than a thumb, its surface dulled by time, its edges worn or scratched. Yet pigment is unlike an ordinary cutting tool. A sharp flake has an obvious mechanical purpose. Ochre does not. It can be used to treat hides, protect skin, aid hafting, mark a surface, colour an object, or take part in practices whose meaning has disappeared. The mineral survives, but intention does not. For Neanderthals, this gap between object and meaning defines one of the most difficult questions in human origins. Evidence from Crimea has sharpened that question. Ochre pieces associated with Makokian Neanderthals show signs of shaping, grinding, scoring, and repeated use. Some appear to have functioned like crayons or marking tools. Their surfaces were not altered only by natural abrasion. They were handled and worked. This does not prove that Neanderthals painted pictures or created art in the modern sense. The marks may have served practical purposes, and scholars still debate how confidently symbolic behaviour can be identified from fragmentary objects. Yet the deliberate preparation of pigment suggests that colour itself mattered. Colour can carry many kinds of importance. Red ochre may be applied to skin, hide, wood, stone, or tools. It may make a surface easier to see, provide a useful chemical property, identify a person or object, or alter appearance for social reasons. A repeated choice of colour may express membership, status, memory, or habit, without producing anything that a modern observer would recognize as formal art. Symbolism does not require painted animals on a cave wall. It begins when an object, colour, or action refers to something beyond its immediate physical function. The problem is that practical and symbolic uses can overlap. Ochre can improve adhesive while also creating a visible red surface. A shell can serve as a scraper, container, or ornament. A feather can be used for warmth, decoration, or ritual display. Archaeologists often want categories to remain separate, but ancient behaviour may not have been organised that way. An object can be useful and meaningful at the same time. Shells provide some of the strongest evidence for this overlap. At several Neanderthal sites, marine shells were collected, modified, coloured, or carried away from the coast. Some contain perforations that may have allowed suspension, others preserve pigment. A shell transported into an inland cave has already moved beyond simple food waste, especially if the species was not edible or the object was selected for appearance. It may have been worn, exchanged, displayed, or kept for reasons that cannot be reconstructed. At Uçazda II cave in southern Turkey, shell ornaments and other behaviours appear within a sequence where Neanderthal and Homo sapiens occupations show notable continuity. This complicates the assumption that personal adornment arrives suddenly with modern humans and cleanly separates one species from another. The cultural transition may have involved persistence, borrowing, shared traditions, or independent choices made within the same landscape. The evidence does not establish identical symbolic worlds, but it weakens the idea that Neanderthals were incapable of attaching social meaning to objects. Bird remains offer another clue. At some sites, Neanderthals selectively removed feathers or claws from raptors and corvids. These parts contain little nutritional value. Feathers decay, leaving cut marks on bones as indirect evidence. Talons may have been modified or retained. One explanation is ornamentation or display. Another is practical use that has not been recognized. No single interpretation fully accounts for every case, but repeated selection of visually striking bird parts suggests attention to qualities beyond meat. This attention may also appear in engraved surfaces, lines cut into bone, stone, or cave walls can be deliberate without being representational. Some Neanderthal-associated marks form repeated patterns or appear too controlled to be accidental damage. Yet a scratched line is among the easiest objects to overinterpret. It may result from butchery, sharpening, testing an edge, counting, idle movement, or intentional design. Context, repetition, microscopic structure, and the order of strokes all matter. The Gorham's cave engraving in Gibraltar is one of the better-known examples. A cross-hatched pattern was carved into bedrock beneath sediment associated with Neanderthal occupation. The grooves required repeated passes with the tool and appear intentional. The design is simple, but simplicity does not remove meaning. It demonstrates that someone chose to alter a durable surface in a way that was not necessary for cutting food or making a weapon. Whether the pattern represented ownership, memory, identity, or nothing comparable to modern symbolism remains unknown. Cave art attributed to Neanderthals has produced even greater controversy. Uranium series dates from Spanish caves have been interpreted as showing that some red marks and mineral formations were created before Homo sapiens are known to have reached Western Europe. If the dates and associations are correct, Neanderthals may have produced abstract cave markings. Critics have questioned contamination, dating methods, and the relationship between mineral layers and pigment. The debate remains active because the claim is significant and the evidence technically difficult. Caution is essential. The desire to recognize Neanderthal creativity can become as distorting as the older desire to deny it. A disputed mark should not be transformed into certainty because it supports a more sympathetic story. The archaeological record must carry the weight. At the same time, demanding a level of proof from Neanderthals that is not always demanded from early Homo sapiens creates another imbalance. Similar objects should be evaluated by similar standards. The deep structures of Bruniquel Cave stand apart because their intentional construction is difficult to dismiss. Far beyond natural light, Neanderthals broke hundreds of stalagmites into sections and arranged them in large rings and piles. Fire was used within the space. The work required illumination, transport, selection, and coordination around 176,500 years ago. There is no obvious domestic reason to build so deeply underground. The cave is not a comfortable campsite, and the structures do not resemble simple windbreaks or hearth surrounds. Their purpose remains unknown. They may have supported activities connected with fire, social gathering, exploration, or practices with symbolic meaning. Calling the site a sanctuary would go beyond the evidence. Calling it meaningless would ignore the extraordinary choice of place and effort. Bruniquel demonstrates that Neanderthals could enter a non-ordinary environment and transform it deliberately. Whatever happened there, it was planned. The treatment of the dead raises similar questions. At several sites, Neanderthal bodies appear to have been placed in pits or protected locations. Some skeletal arrangements are difficult to explain through natural collapse alone. At Shanidar Cave, the position and context of Shanidar Z support the possibility of deliberate burial. Older claims that flowers were placed with another body remain controversial because pollen may have been introduced by burrowing animals. The romantic image of a flower burial is therefore uncertain, but the broader question of intentional deposition remains open. Burial does not automatically prove religion, belief in an afterlife, or ritual resembling later human traditions. A body may be covered for hygiene, protection from scavengers, emotional attachment, or practical reasons. Yet even practical burial recognizes the dead person as socially significant. Time and labor are spent. A location is chosen. The body is treated differently from ordinary refuse. Repeated use of the same cave areas for bodies may indicate memory across generations. People returning to a shelter could have known that others lay beneath the floor, even if the exact individuals were forgotten. place, death, and community may have become linked. The evidence cannot reveal whether grief was expressed through words, touch, silence, or repeated action. It can only show that some bodies were not treated as anonymous remains. Symbolic behavior is often imagined as a switch that turns on suddenly in one species. The archaeological record suggests something less tidy. Meaning may emerge gradually through pigments, decorated bodies, unusual objects, remembered places, and repeated customs. Some behaviors leave clear traces, others vanish completely. A painted hide, a feather arrangement, a gesture over the dead, or a pattern drawn in ash can disappear within days. Neanderthals may therefore have possessed forms of expression that archaeology is poorly equipped to detect. Their cultures were likely carried heavily in perishable materials, bodies, voices, and movement. The surviving record favours stone and bone, producing a world that looks more practical than it may have felt to the people living within it. The question is not whether every Neanderthal marked surfaces, wore ornaments, or buried the dead. Human cultures vary, and Neanderthal communities probably did as well. The question is whether they were capable of creating shared significance. Pigment prepared for marking, shells transported and altered, bird parts selected without nutritional reason, engraved patterns, deep cave structures, and deliberate treatment of bodies all point in that direction. None provides a complete symbolic system. Together they form an edge of evidence, a place where function and meaning blur. Beyond that edge lies most of what made Neanderthal life inwardly human identities, attachments, memories, fears, and understandings that were never written down. The ochre remains in the sediment, the mark remains on the stone. The meaning went with the hand that made it. The marks, ornaments, and altered spaces left by Neanderthals become even more difficult to interpret once another human population enters the same world. Homo sapiens did not arrive in Eurasia as explorers stepping onto an empty continent. They moved through landscapes already known, named, hunted, and remembered by other people. Neanderthals had occupied much of Europe and Western Asia for hundreds of thousands of years. Farther east lived Denisovan populations known mostly through fragments of bone, teeth, and DNA. Other human groups may also have existed without leaving remains that science has yet recognized. The late Pleistocene was not a stage with one human actor waiting to inherit the Earth. It was a meeting ground. These meetings unfolded over immense distances and many generations. There was no single moment when modern humans arrived and confronted all Neanderthals at once. Homo sapiens moved out of Africa in several dispersals, some of which may have ended without leaving large surviving populations. In the Levant, modern humans and Neanderthals occupied the same broad region at different times, long before the final expansion of Homo sapiens into Europe. Climatic changes repeatedly altered which routes were open and which populations could remain. Caves changed occupants. Tool traditions appeared, persisted, or disappeared. The archaeological record preserves a sequence of presences, but rarely the face-to-face encounter itself. Tinshemet Cave in present-day Israel offers a glimpse of this shared behavioral landscape between roughly 130,000 and 80,000 years ago. Human remains, stone tools, ochre, animal exploitation, and possible burial practices suggest a degree of behavioral similarity among different Homo populations in the Levant. The evidence does not allow every object to be assigned confidently to a particular species, and that uncertainty is itself revealing. If Neanderthals and Homo sapiens can use comparable tools, hunt in similar ways, handle pigments, and treat bodies with similar care, then material culture does not always function as a biological label. This does not mean the populations were identical. They had distinct evolutionary histories and anatomical patterns. Their communities may have differed in language, social organization, movement, and tradition. Yet cultural behavior can cross boundaries that anatomy does not. A useful tool can be copied. A method of preparing stone can be learned. A shell ornament can be noticed, desired, and adopted. Traditions may spread through observation, exchange, or people moving between communities. At Uchazla II Cave in southern Turkey, research published in 2026 strengthened the possibility of long-term cultural continuity across periods associated with Neanderthals and Homo sapiens. Hunting practices, stone technology, resource use, and shell ornaments do not show a simple break in which one species arrives and an entirely new world begins. Instead, some behaviors appear to continue across the biological transition. Scholars remain cautious about whether this reflects direct teaching, shared regional traditions, parallel adaptation, or a mixture of these processes. What survives in the record suggests that cultural identity was not always confined within species identity. For most of archaeological history, researchers could only infer contact from tools and bones. Ancient DNA changed the scale of the question. In 1997, mitochondrial DNA recovered from the original Neander Valley fossil confirmed that Neanderthals represented a population distinct from recent humans. Later nuclear genomes transformed the story again. When scientists compared Neanderthal DNA with the genomes of living people, they found that many modern humans outside sub-Saharan Africa inherited a small proportion of their ancestry from Neanderthals. The implication was unavoidable. Neanderthals and Homo sapiens had children together, and some of those children entered populations whose descendants survive today. The old image of complete replacement could no longer stand. Neanderthals had not simply vanished before modern humans became established. Their histories overlapped biologically. Genomic studies place a major period of interbreeding between the ancestors of many living non-African populations and Neanderthals, around 45,000 to 50,000 years ago, though contact occurred at other times as well. Some early Homo sapiens fossils contain Neanderthal ancestors only a few generations back, revealing encounters close enough in time to appear directly within an individual genome. These were not abstract exchanges between species. They involved real people forming relationships, whether briefly or permanently, within communities whose social responses cannot be recovered. The nature of those relationships remains unknowable. Genetics proves reproduction, not affection, equality, conflict, or consent. Encounters across the Pleistocene were probably as varied as encounters among human groups have always been. Some may have involved cooperation and incorporation. Others may have involved competition or violence. Many may have passed without lasting genetic consequences. It would be misleading to imagine a single pattern governing thousands of years across an entire continent. The children of mixed ancestry complicate the boundary around both populations. They inherited biological traits from Neanderthal and Homo sapiens parents, but culture would have been learned from the people around them. A child might have grown within a Neanderthal community, a modern human community, or a group containing ancestry from both. Species labels created by later science cannot tell us how that person understood belonging. Not every inherited Neanderthal gene remained in modern populations. Natural selection removed many variants, especially in regions of the genome where incompatibilities affected fertility or development. Other variants persisted because they were neutral or useful. Neanderthal ancestry has been associated with aspects of immunity, skin biology, metabolism, pain sensitivity, sleep patterns, and adaptation to Eurasian environments. These effects are usually small and complex. They do not produce a hidden Neanderthal personality within living people. They are fragments of ancient biological experience preserved within modern genomes. The genetic record also reveals contact with Denisovans. Neanderthals and Denisovans share a common ancestral population after its separation from the lineage leading mainly to Homo sapiens. They later diverged, but the separation was incomplete. DNA from Denisova Cave in Siberia identified an individual whose mother was Neanderthal and whose father was Denisovan. This first-generation child, sometimes called Denny, provides direct evidence that the two populations met and reproduced. Her genome turns a remote evolutionary diagram into a family history. One parent belonged to a Neanderthal population related to groups from Western Eurasia. The other carried Denisovan ancestry and traces of even older Neanderthal mixing. The Altai region was therefore not an isolated edge of humanity. It was a corridor where different populations arrived, departed, and encountered one another. Denisova Cave itself preserves this changing human presence. Neanderthals used it. Denisovans used it. Material culture accumulated through separate occupations, while genetic fragments survived in bones and even sediments. The cave demonstrates how misleading a single species name can be when attached permanently to one location. Over tens of thousands of years, the same shelter can belong to different populations, each inheriting a landscape already marked by others. Neanderthal DNA also reveals movement within their own range. Populations were replaced or mixed over time. Siberian Neanderthals could be genetically connected to groups far to the west. Late communities in Europe were not one uniform, collapsing remnant. Research on Neanderthals from Belgium and France has shown more diversity and connection than some simple extinction models predicted. Small populations could still maintain regional relationships, although those networks varied and were vulnerable to disruption. Archaeology and genetics do not always tell the same story at the same resolution. Stone tools can spread without people moving far. Genes can move through a small number of individuals while local technology remains unchanged. A population may adopt another group's methods without substantial interbreeding, or absorb outsiders whose descendants continue making familiar tools. Culture, anatomy, and ancestry overlap, but they do not travel together in predictable proportions. This is why the transition from Neanderthal to Homo sapiens occupation can look gradual in one region and abrupt in another. At some sites, new blade technologies, ornaments, or settlement patterns appear close to the arrival of modern humans. Elsewhere, Neanderthals already used pigments, ornaments, bone tools, or techniques once treated as exclusively modern. In still other places, the evidence is too damaged to support a clear sequence. The encounters therefore resist a simple story of superior newcomers replacing inferior residents. Homo sapiens may have possessed larger or more resilient social networks in some regions. They may have exchanged information across greater distances, recovered more effectively from local population losses, or adapted rapidly through cultural connections. Neanderthals possessed their own deep environmental knowledge, technologies, and social bonds. The outcome depended not on a single contest of intelligence, but on demography, climate, geography, chance, and relationships unfolding over generations. By the time modern humans spread widely through Europe, they were not moving through a world untouched by other minds. They entered caves where fires had burned long before them, crossed routes followed by older communities, and perhaps learned techniques whose origins they did not know. They met people whose faces differed but whose tools, gestures, ornaments, and concerns could be understood. The boundary between them was real, but it was permeable. It could be crossed by an object, an idea, a traveller, or a child. Ancient DNA has made that crossing visible. Neanderthals were not merely replaced figures standing outside the modern human story. For a time, they were neighbours, competitors, teachers, partners, and relatives. Part of their history became ours before their distinct populations disappeared. The word builder usually brings stone walls to mind. It suggests foundations, roofs, streets, and structures that remain visible long after their makers are gone. Neanderthals leave almost nothing of that kind. They establish no known cities, raise no monuments above the landscape, and carve no permanent architecture into the open ground. Yet this absence can be misleading, because building does not begin with masonry. It begins whenever people deliberately alter space to make it safer, warmer, more useful, or more meaningful. For a mobile Ice Age population, permanence can be a disadvantage. A fixed house cannot follow migrating animals, escape a failing water source, or move when winter closes a valley. Neanderthal shelters were likely designed for the duration of need. A windbreak might stand for several nights. A hide covering could be dismantled and carried. Branches, poles, stone weights, and bedding could be assembled from nearby materials, then abandoned when the group moved on. Such structures may have been highly effective while leaving almost nothing that archaeology can recognize. Wooden posts rot, hides disappear, fibers decay. Stones used to anchor coverings can be scattered by animals, frost, flowing water, or later occupation. Even when a pattern survives, distinguishing a deliberate structure from natural debris is difficult. Archaeologists must examine the position of stones, distributions of artifacts, sediment disturbance, possible post-impressions, and the relationship between hearths and working areas. A convincing shelter is rarely identified through one feature alone. At the open-air site of La Folie in France, a roughly circular concentration of artifacts and traces interpreted as post-placements has been proposed as evidence for a Neanderthal windbreak or shelter. A ring of limestone blocks may have helped secure the base of a covering. The interpretation is plausible rather than absolute. Thousands of years of soil movement can imitate patterns, and the organic upper structure is gone. Still, the site provides a possible view of Neanderthals constructing protection beyond the convenient walls of caves. Other open-air sites preserve concentrations of tools and bones around hearths, sometimes with gaps or boundaries suggesting that people worked within defined spaces. These arrangements may reflect tents, windbreaks, or simply repeated behavior around fire. The evidence remains incomplete because a campsite can be reorganized many times. People step on debris, sweep areas, move tools, and rebuild hearths. Later occupations overlap earlier ones. The resulting pattern is a compressed history of movement rather than a perfectly preserved floor. Even so, spatial organization appears repeatedly. Sharp stone waste may be concentrated where tools were made, away from sleeping or food preparation areas. Animal carcasses may be processed at the edge of a camp to reduce mess and attract scavengers away from the hearth. Useful tools are carried inward. Unwanted bone and broken stone are pushed aside. Fuel is stacked where it remains dry. Hides are worked where light and space allow broad movements. These choices create zones without walls. A hearth itself is a form of architecture. It changes temperature, light, air movement, and the use of surrounding ground. Some fires are placed against cave walls that reflect heat. Others occupy shallow depressions or are bordered by stones. Fuel may be selected for heat, smoke, duration, or availability. A fire intended for cooking differs from one used briefly for light or material processing. Repeated burning can create thick lenses of ash that mark the center of occupations separated by centuries. The engineering lies not in complexity for its own sake, but in control. A fire too close to a hide covering can destroy shelter. One placed too deep inside a cave can fill the chamber with smoke. A poorly protected flame may die under rain or wind. Neanderthals must understand how air moves through entrances, where sparks travel, and which fuels produce manageable heat. This knowledge is practical, learned through consequences rather than written rules. Caves amplify these decisions. Their stone walls provide shelter, but they also impose limits. The deepest areas may be damp or poorly ventilated. The entrance can become a channel for cold air. Smoke may collect beneath low ceilings. Water can run across the floor after storms. Neanderthals choose particular zones within caves, often near enough to daylight for work and far enough inside for protection. Repeated hearth placement suggests that some positions were consistently better than others. Bedding may have helped transform hard cave floors. Plant remains at some Middle Paleolithic sites have been interpreted as grasses, branches, or other material gathered for sleeping surfaces, though preservation is rare and attribution can be uncertain. Hides could add insulation. A raised or layered bed reduces heat loss into cold ground and separates sleepers from damp sediment. It is a modest technology with substantial value, especially during long nights. The construction of clothing and containers further extends architecture onto the body. A fitted hide covering creates a portable boundary against wind. Foot protection turns frozen or rocky terrain into more usable ground. A bag expands the amount of fuel, food, or tools that can be moved. Cord ties components together. In this sense, Neanderthals build not only shelters, but systems of protected mobility. Some of the most ambitious interpretations involve large animal bones. At Molodova, in present-day Ukraine, a circular accumulation of mammoth bones associated with Middle Paleolithic artifacts has been proposed as part of a Neanderthal structure or windbreak. Other researchers argue that natural processes, scavenging, or repeated butchery could have produced the pattern. The site illustrates the central difficulty an arrangement can resemble architecture, while preserving too little evidence to prove a roof or wall existed. Later, Homo sapiens sites contain clearer mammoth bone dwellings, but those examples should not be projected backward automatically. Neanderthals may have used large bones structurally when wood was scarce, yet each claimed structure must be judged on its own evidence. A sympathetic reconstruction can become as speculative as the old caricature it replaces. Bruniquel Cave avoids some of this ambiguity. Deep underground, hundreds of broken stalagmite sections form large rings and smaller accumulations. The material was selected, broken to similar lengths, moved, stacked, and arranged. Burned areas show that fire was maintained within the chamber. Natural forces cannot easily explain the complete pattern. The people who created it entered more than 300 meters into darkness. They had to carry reliable light or establish fires along the route. They needed to remember the passage back to the entrance, move across uneven ground, and continue working where daylight offered no guidance. The rings required many pieces and repeated placement. Whether the work took hours, days, or several visits remains unknown, but it was coordinated. Its purpose is still hidden. The structures do not form an obvious dwelling. The deep chamber lacks the convenience of a normal camp, and no clear practical activity explains the effort. It may have been connected with exploration, fire management, gathering, social performance, or behavior with symbolic significance. Scholars still debate how much can be inferred. Bruniquel proves construction and organization, not the beliefs behind them. Yet the mystery of its purpose is part of its importance. Neanderthals were willing to transform a space that offered no immediate daylight, hunting advantage, or ordinary comfort. They carried intention into darkness. The rings are not cities or monuments, but they are deliberate structures created within a place that nature had already shaped over thousands of years. Building also appears through landscape management. At Neumark Nord, repeated use of lakeside areas for animal processing suggests organized activity on a large scale. Bones were transported, broken, and concentrated. Fire affected local vegetation, perhaps creating more open areas around the lakes. Whether this environmental change was intentional remains debated, but Neanderthal presence was sustained enough to leave an ecological signature. Such places challenge the idea that they merely pass through landscapes without altering them. They organized carcass processing zones, maintained fires, selected routes, reused camps, and deposited materials in patterned ways. Their constructions were often processes rather than objects. A campsite became more functional through repeated modification. A cave became familiar through generations of return. A lakeshore became a workshop through accumulated labour. The scale remained different from that of later settled societies. Neanderthals did not store harvests behind walls or build infrastructure for thousands of inhabitants. Their communities were small, and mobility remained central. But judging their architecture by the absence of villages is like judging a ship by its failure to become a house. Their structures answered another set of needs. They built against wind rather than for ownership. They arranged space for cooperation rather than administration. They created warmth where none existed, light inside darkness, and temporary stability within climates that would not remain stable. Their architecture was made from materials intended to serve life, not archaeology. The surviving evidence is frustratingly thin because successful mobile structures often vanish by design. A hide shelter leaves no ruin when it is dismantled. A wooden frame returns to soil. A hearth becomes a stain. A camp known for generations can disappear beneath a river or modern sea. What remains may be only a pattern of stone flakes curving around an empty place where a wall once stood. Neanderthals were builders without cities because cities were not the measure of their world. Their achievement was to make small regions of the Ice Age temporarily habitable and socially ordered. They built spaces where tools could be taught, food shared, injuries tended, and darkness held at a distance. These constructions did not conquer the landscape. They allowed people to remain within it, season after season, until changing conditions forced the paths of human populations into their final and most uncertain convergence. By the time Homo sapiens begins spreading widely through Europe, Neanderthals have already survived climatic reversals, population contractions, and regional disappearances many times before. Their final decline, therefore, does not begin as an obvious catastrophe. There is no single moment when the last communities across Eurasia vanish together. Instead, their archaeological presence thins unevenly. In one region, Neanderthal tools continue after they have disappeared elsewhere. In another, modern human occupations appear nearby or replace them after an uncertain gap. Caves preserve interrupted sequences. Dates overlap at the edges of their error ranges. The end emerges not as one clean boundary, but as a patchwork of local endings. For decades, this disappearance was explained through a simple contest. Homo sapiens arrived with better minds, better weapons, better language, and better art. Neanderthals, supposedly less capable, were pushed aside. The story was easy to remember because it resembled a familiar evolutionary ladder. It is also increasingly difficult to defend. Neanderthals hunted cooperatively, controlled fire, prepared composite tools, worked hides and fibers, cared for injured members, used pigment, constructed spaces, and sometimes shared or sustained cultural practices comparable to those of early modern humans. Intelligence may have differed in organization or expression, but there is no persuasive evidence that Neanderthals disappeared because they were simply too foolish to survive. Their vulnerability may instead have begun with numbers. Neanderthal populations were small, dispersed, and often separated by difficult terrain. Ancient DNA suggests that some communities experienced low genetic diversity and close biological relationships. In a small population, chance becomes powerful. A few unsuccessful seasons, the loss of several adults, or the failure of births to balance deaths can reduce a community below the level needed for long-term survival. The disappearance of one group may leave a large territory empty even when no dramatic conflict occurs. Small numbers also make specialized knowledge fragile. A community may depend on only one or two people who know a distant water source, a difficult tool-making method, or the timing of animal movement through a mountain pass. If those individuals die before their knowledge is fully transmitted, the loss is cultural as well as demographic. A larger, more connected population has more copies of the same information. Skills can disappear locally and later be reintroduced. In an isolated group, one break in transmission may be permanent. This does not mean every late Neanderthal population was genetically exhausted or socially cut off. Research on individuals from Belgium and France has revealed surprising diversity among some of the last Neanderthals in northwestern Europe. Certain communities remained connected across regions and cannot be described as a single inbred remnant waiting for extinction. The finding matters because it prevents one genetic explanation from being stretched across the entire continent. Neanderthal populations differed. Some were isolated, others maintained movement and contact. Their final decline probably followed several regional paths. Climate added pressure, but climate alone cannot solve the mystery. Neanderthals had survived numerous cold periods and rapid environmental changes before Homo sapiens became widely established in Europe. They were not helpless in unstable conditions, yet the climatic fluctuations around their final millennia may have fragmented habitats at the same time that new human populations entered them. Open landscapes contracted or shifted. Forests expanded in some areas and retreated in others. Prey distributions changed. A hunting territory that had supported a community for generations could become unreliable within a comparatively short span. The critical issue may have been not the severity of any single cold event, but the ability to recover from repeated shocks. If one region became temporarily uninhabitable, a population needed access to alternative territory, neighboring communities, and enough people to recolonize when conditions improved. A small network can survive ordinary difficulty yet fail when disruptions arrive too close together. Climate becomes dangerous when it breaks connections. Recent modeling has emphasized this difference in connectivity. Homo sapiens populations may have been linked through wider, more flexible social networks, allowing information, materials, and people to move across greater distances. If a local group suffered loss, outsiders could arrive, partners could be found elsewhere, and knowledge could circulate through several routes. Neanderthal networks may have been effective within familiar regions, but less resilient when large areas became fragmented. This remains a model rather than a complete reconstruction. Archaeologists cannot map every relationship, and raw material movement does not translate directly into friendship, alliance, or population support. Still, network size offers a way to explain how two populations with many comparable abilities could experience different outcomes. Survival may depend less on how clever one individual is than on how many communities remain connected when local knowledge fails. Diet may also have contributed. In some regions, Neanderthals relied heavily on large herbivores, while Homo sapiens appear to have exploited a wider range of small game, fish, birds, and plant resources more intensively. But the contrast should not be exaggerated. Neanderthal diets were regionally flexible, and modern human groups also depended heavily on large animals. The important difference may have been the speed with which subsistence strategies spread through social networks rather than the absolute ability to eat a particular food. Technology presents a similar problem. Early Homo sapiens often produced blades, projectile points, bone tools, ornaments, and other objects in combinations that differ from many Neanderthal traditions. Some weapons may have allowed killing from greater distance, reducing risk. Lighter toolkits may have supported wider mobility. Yet Neanderthals also developed varied technologies, and several supposedly modern behaviors appear in their contexts. There was no single invention that suddenly made Neanderthal survival impossible. Competition for territory and resources almost certainly occurred. Two human populations using the same water sources, caves, stone deposits, and prey could not always avoid one another. Homo sapiens may have occupied strategic corridors or productive regions, gradually restricting Neanderthal movement. Direct violence is possible, but evidence for organized warfare between them is lacking. A population can be displaced without repeated battles if newcomers arrive in slightly larger numbers, return more quickly after bad seasons, and maintain broader alliances. They can absorb territory generation by generation. Disease is another plausible factor. Groups separated for long periods carry different histories of exposure and immunity. Contact can introduce infections to which one population has limited resistance, yet ancient diseases are exceptionally difficult to identify, and no epidemic has been shown to explain the disappearance. Disease may have contributed locally without being the main cause everywhere. Interbreeding creates a more subtle form of disappearance, because Neanderthals and Homo sapiens had children together. Some Neanderthal communities may have been absorbed rather than exterminated. If small groups repeatedly joined larger modern human populations, their distinct anatomical and cultural identity could fade while portions of their ancestry continued. This process does not require a final isolated individual standing alone. It can occur through ordinary relationships across many generations. The amount of Neanderthal DNA in living people is modest, which means absorption cannot account for their entire population. Much ancestry was removed by natural selection, or diluted as Homo sapiens numbers expanded. Still, genetic survival makes the word extinction incomplete. Neanderthals disappeared as a recognizable population, but not every lineage ended. Their final dates also remain debated. Most evidence places the disappearance of Neanderthals around 40,000 years ago, though claimed later survival in certain refuges has generated controversy. Dating cave layers is difficult. Sediments can mix, old carbon can contaminate samples, and tools may be assigned to a species without fossils directly beside them. Some supposed late sites have become older after improved analysis. Others remain uncertain. The idea of isolated survivors lingering for thousands of years is possible in principle, but it has not been demonstrated securely in every proposed region. The last Neanderthal population may never be identified. It could have lived in Iberia, the Balkans, Italy, Western Asia, or some landscape now submerged beneath the sea, its members would not have known they were the final representatives of a lineage. They would have followed familiar routes, repaired tools, maintained fires, and watched the same weather signs their ancestors had read for generations. Extinction is visible only from the future. No single explanation fully accounts for what happened. Climate changed, but Neanderthals had endured climate before. Homo sapiens competed, but also exchanged genes and perhaps ideas with them. Some Neanderthal groups were isolated, while others remained diverse and connected. Technology mattered, but no magical tool decided the outcome. Disease, diet, demography, mobility, and chance may all have contributed in different proportions. The most convincing picture is cumulative. Small populations face repeated environmental pressure. Their networks become fragmented in some regions. Homo sapiens arrive with larger numbers and wider connections. Competition reduces access to territory. While interbreeding absorbs individuals and families, local groups disappear one after another, not because they cease to be intelligent, but because resilience depends on more than intelligence. Their end was therefore not the defeat of a failed human experiment. It was the loss of a successful form of humanity under a rare convergence of pressures. For hundreds of thousands of years, Neanderthals built life within unstable landscapes. In the end, the world changed faster than their scattered populations could rebuild their connections. What disappeared was not capability, but continuity. Neanderthals did not leave behind a written name for themselves. The word used today comes from a German valley where a partial skeleton happened to survive, not from anything these ancient people called their families, territories, or kind, their own names, if they used them, vanished with their voices. Yet disappearance did not erase them completely. Their remains endured in caves, their tools persisted in river terraces, and fragments of their biology passed into the bodies of people who would never know where that inheritance began. For many living populations outside sub-Saharan Africa, a small proportion of the genome derives from Neanderthal ancestors. The amount varies among individuals and regions, and it should not be imagined as one intact block of ancient identity. Neanderthal ancestry survives as scattered fragments distributed across chromosomes, the result of interbreeding, recombination, population movement, and natural selection over tens of thousands of years. One person may carry variants, another does not. Across humanity as a whole, far more of the Neanderthal genome survives collectively than any single individual contains. These fragments influence biology in subtle ways. Some Neanderthal-derived variants are associated with immune responses, skin and hair traits, metabolism, blood clotting, sleep rhythms, pain sensitivity, and vulnerability to particular diseases. Their effects are rarely simple. A genetic variant useful in one ancient environment may become disadvantageous in another. An immune response that helped confront Eurasian pathogens can increase the risk of inflammatory conditions under modern circumstances. A trait connected with adaptation to seasonal light may interact differently with artificial illumination and indoor life. This does not mean that people carrying more Neanderthal DNA behave more like Neanderthals, nor that personality, intelligence, or temperament can be reduced to ancient ancestry. Popular claims about a Neanderthal gene for aggression, depression, strength, or solitude usually stretch complex research beyond what it can support. Modern traits emerge from many genes interacting with development and environment. The genetic legacy is real, but it is not a hidden caveman waiting inside the modern mind. Its deeper importance lies in what it reveals about human history. the genome shows that ancient populations once classified as separate branches did not remain entirely separate. Their boundaries were crossed. People met, reproduced, and incorporated descendants into communities. Neanderthals are therefore not simply an extinct group observed from outside. They became part of the ancestry of later humans. Their legacy may also survive culturally, though culture is much harder to trace than DNA. A technical method can be copied without leaving evidence of who invented it. A useful idea can pass from one population to another and continue long after its origin is forgotten. Bone tools, hide working, ornaments, pigment use, hunting strategies, and stone traditions sometimes appear across periods of contact between Neanderthals and Homo sapiens. At sites such as Uchiasla II, continuity across occupations suggests that a change in population did not always erase regional knowledge. It is possible that some behaviours carried forward through direct learning. A modern human group entering unfamiliar terrain could benefit from knowledge held by people already adapted to it. Neanderthals knew local animal routes, stone sources, caves, seasonal water, and the dangers of particular landscapes. Contact may have transferred some of that information. Archaeology cannot usually distinguish a borrowed method from an independently discovered one, so the scale of cultural inheritance remains uncertain. Still, the idea that every useful tradition arrived solely with Homo sapiens is no longer safe. Even where no direct transmission occurred, Neanderthals expand the known range of human possibility. They demonstrate that large brains, social care, composite technology, coordinated hunting, controlled fire, spatial construction, pigment use, and treatment of the dead were not exclusive achievements of one surviving lineage. These behaviours emerged in more than one human population, sometimes independently and sometimes through contact. Humanity's defining qualities may therefore be older and more widely shared than the history written by the survivors once suggested. This recognition has changed museum reconstructions. The stooped brute has gradually given way to figures standing upright, wearing practical clothing, holding carefully made tools, and looking outward with expressions that do not exaggerate either savagery or modern familiarity. Reconstruction remains interpretation. Skin colour, hair, facial soft tissue, clothing style, and ornament can rarely be known with certainty. Yet the shift reflects something larger than improved artistic technique. It reflects a change in the moral distance placed between them and us. Earlier generations often used Neanderthals as an insult. To call someone Neanderthal was to call that person crude, violent, unintelligent, and incapable of refinement. The insult survives even as the science beneath it collapses. It says more about modern prejudice than about the ancient population. Neanderthals were certainly capable of violence, as all human populations are. They hunted, competed, suffered injury, and may have fought. But they also cared for impaired companions, maintained social bonds, taught complex skills, and built places of warmth and order. No honest account can reduce them to either monsters or gentle idealized relatives. Their humanity does not depend on making them identical to Homo sapiens. Difference deserves to remain. Their bodies developed along another path. Their brains may have been organized differently. Their communities may have been smaller, their social networks structured in other ways, and their communication unlike any language spoken today. Some of their capacities may have exceeded ours in domains shaped by their world-reading animal movement, navigating without maps, recognizing stone quality by touch, maintaining life through climatic instability, or remembering landscapes across generations. To declare them human only after making them resemble ourselves would repeat an old mistake. the more revealing conclusion is that human-like existence can take more than one form. Neanderthals were a distinct kind of ancient human, not failed modern people. Their achievements should be understood within the conditions they faced rather than measured solely against cities, writing, agriculture, or modern art. The phrase Ice Age builders therefore carries several meanings. They built weapons from wood, stone, adhesive, and fibre. They built fire in places where warmth could not be assumed. They built clothing and portable shelter from hides that almost never survive. They built spatial order in caves and camps. At Bruniquel, they built enduring structures deep in darkness for reasons still unknown. At Newmark Nord, they organized landscapes of butchery, food processing, and repeated return. Within their communities, they built relationships strong enough for injured and dependent members sometimes to survive. Above all, they built continuity. Each generation inherited techniques, roots, and habits from the one before it. A child watching stone fracture learned movements already ancient. A hunter carrying a wooden spear depended on knowledge refined by people long dead. A group returning to a cave stepped across traces of earlier fires. Culture allowed Neanderthal lives to reach beyond individual memory, just as it does in every human society. That continuity finally broke as a distinct population, but not because everything they made failed. Their technologies worked for hundreds of thousands of years. Their bodies carried them across a vast portion of Eurasia. Their communities survived glacial advances, warmer forests, droughts, predators, and repeated ecological disruption. A lineage that persists for such a span cannot be described honestly as unsuccessful. Homo sapiens has existed in its present anatomical form for roughly 300,000 years. Neanderthal history covers a comparable order of deep time when their earlier developmental roots are included. From their perspective, they were not approaching an ending for most of their existence. They were living within a durable world of inherited solutions. The arrival and expansion of modern humans was one late event in an ancient story. The final Neanderthals may have noticed new people appearing along familiar routes. They may have seen unfamiliar tools, heard unfamiliar speech, exchanged objects, formed families, avoided strangers, or joined them. Some communities probably disappeared without meeting Homo sapiens directly, undone by local demographic failure or environmental change. Others entered the expanding population genetically and socially. The end took many forms. Their surviving DNA turns extinction into a quieter transformation. The distinct faces vanish from the fossil record, but some biological inheritance continues in descendants whose appearance is overwhelmingly Homo sapiens. Their technical contributions, if any were adopted, became anonymous. Their camps were buried. Their coastlines drowned. Their fires went out one by one. Yet not every trace of the people around them was lost. The question of how human they were once assumed that modern humanity stood at the centre, and Neanderthals waited at some measured distance from it. The evidence now changes the geometry. There was no single centre. Several human populations inhabited the Pleistocene, each carrying its own mixture of biological history, culture, intelligence, and adaptation. Homo sapiens is the only one still present as a distinct population, but survival does not grant exclusive ownership of humanity. Neanderthals were human enough to plan for futures they could not see, to maintain the lives of others, to shape materials according to imagined forms, and to transform cold ground into inhabited space. They were human enough to leave evidence that cannot be separated cleanly into practical action and meaning. They were also different enough to remind us that the human family was once broader than it is today. And now the scale of the story begins to widen. The caves remain, but their entrances change. Sediment rises slowly over hearths. Water moves through cracks in limestone. A wooden spear darkens beneath ancient soil, while forests return and disappear above it. Along the shore of a lake, broken bones sink into mud. Far inside Bruniquel cave, rings of stone wait in darkness through the arrival of modern humans, the end of the Ice Age, the growth of villages, the rise of cities, and every empire that believed itself permanent. Time does not preserve lives evenly. It keeps a tooth and loses a face. It keeps a stone flake and loses the hand. It keeps a fragment of DNA while erasing the names of everyone who carried it. Much of the Neanderthal world is gone not because it was empty, but because most human experience is made from things that cannot endure voices, gestures, warmth, trust, fear, instruction, and memory. For a while, every Neanderthal life existed in the present. The next winter mattered more than distant extinction. A fire needed fuel. A tool needed repair. Someone returned late from the plane. Someone else watched the entrance. Food was divided. Hides were drawn closer against the cold, and knowledge moved quietly from one generation to another. No one inside that circle knew they belonged to a vanished form of humanity. Modern people stand at another fire, surrounded by technologies that appear permanent and records that seem too numerous to disappear. Yet the Neanderthal story offers a gentler warning. Survival is not proof of destiny, and disappearance is not proof of failure. A human world can endure for immense spans, adapt with extraordinary skill, and still become almost silent. What remains is enough to disturb the silence, but not enough to fill it completely. Their bones tell us they were strong. Their wounds tell us they survived together. Their tools tell us they planned. Their structures tell us they transformed space. Their pigments suggest that surfaces could hold more than utility. Their genes tell us that the boundary between their story and ours was crossed. Beyond those traces lies everything that cannot be recovered. The sound of their speech under a cave roof, the route remembered by one person and taught to another, the meaning of red colour on skin or stone, the reason people carried light deep underground and arranged broken stalagmites into rings, the expression on a familiar face returning through snow. The last image is not of a brute disappearing into darkness. It is of a small fire in a changing landscape. Around it sit people whose bodies belong to another branch of humanity, while their needs feel close enough to recognize. The wind continues beyond the light. The cold presses against the shelter. Hands move carefully over stone, wood, hide, and flame. For one more night, the fire holds, the group remains together, and an ancient human world is still alive.